Hello, hi, namaskar everyone. My name is Deepender and I welcome you all to the super one shot for class 11 students of boards. Yes, the first lecture of your 11th and 12th preparations series. Yes, I welcome you all in this amazing, in this phenomenal series where with these one shots will be helping you or assisting you in covering your boards preparation. Indeed, whatever I've said is completely true. Yes. Whether you're in 11th standard or in 12th standard, preparing for your boards and confused where to prepare it from for free of cost at absolutely no cost, if you are worried about this, that you want to prepare for your boards in English, your concern has been addressed. Not just addressed, but it is very well resolved. Look at the screen right there in front of you. Yes, we are here with this series, and the first session in this series is your 11th class mathematics first lecture, sets. So without any delay, we'll straight away get started. First of all, I hope you have understood the agenda. Just give me a quick update, a response in the chats. Am I clearly visible and audible? And with this, we'll straight away get started. I'll be conducting a lot of polls in this session. So if you want to participate in those polls, if you want to tell me which option do you get correct, then of course you can with the feature of PyLens. This is an application which you can download from Google Play Store and you can actively participate in the polls. And along with this, of course, if you're watching it on the laptop or desktop with the Chrome store, you can download it. Shall we get started? But yes, I want to tell you one more very amazing, exciting feature of this PyLens, that if you're watching any random video on YouTube, you want to generate short notes, mind maps, previous year's questions or quizzes on it, you can. I repeat, any random video if you're watching on YouTube, with this application PyLens, you can generate a lot of things based on that. With this, we are straight away getting started with this chapter sets. There is no recap of the previous chapter. Today, we'll straight away start with this session. But what is my expectation? Let me set my expectations. So in this series, what should you expect and what can I expect, or what are my expectations? Both I'll tell you. My expectation is pretty simple. I'll expect and hope that you stay consistent, you stay regular, and you watch these sessions completely and thoroughly. You don't lose your focus, you don't lose your attention. Yes, because great things in life require great efforts. So here, if you want to achieve something, which means with this one shot, you want to understand this chapter completely, thoroughly, absolutely, and exhaustively, here you have an opportunity. Not just that, after this session, I'll be hoping and assuming that you don't assume that this chapter is totally covered. From my end, it is absolutely covered, but from your end, we'll be considering it to be covered if you are practicing relevant questions. Two things I'll be hoping and expecting: that in every single class, you stay consistent, you understand everything clearly, and the most important thing, whenever in doubt, raise your hand and ask. This is what we say in offline classes. Here I'll say, whenever you have doubt, you have this feature of chat. Just post your queries and concerns there. I'll be happy to resolve and address those. Shall we get started, everyone? Everyone with me. Now, what can you expect? With this one shot of sets, we'll be covering this entire chapter with relevant and apt examples. So with this, we are getting started. I'm sure everyone is ready and all set. Sir, in this chapter sets, what all will be covering? First of all, I'll be taking you towards the basics of sets, that what all are sets, different types of sets. Then we'll be understanding different operations on set, cardinal number, power sets, subsets, and then of course, with the word problems, we'll be concluding this chapter. So first of all, I'll take you through the theory and then gradually we'll move towards the questions. So first of all, what do you understand by the set? Set simply means that a collection. Collection means what? Collection means, let's say you all are my dear students, you're watching this session. So if I club you all, let's say we have some students in front of us who are, I think, Mandakini, Smart Boy. So if I club these people, Mandakini, Smart Boy, like some other students are there, and if I write all of these people in this set here, these are the elements of the set. Which set? The set which we have started is a series for class 11. So let's say class 11's students set, I'm denoting by a capital letter X. So this is a set which is a collection of some elements, and here the constraint is that these elements are those students who are watching this session. Excellent. Good. Keep it up. Excellent, Mandakini. I hope you got it. Everybody comfortable with this concept of sets? But here you need to understand sets can be finite or infinite. Sir, what do you mean by that? Of course, let's say if I tell you about a set, which is the set of, let's say, vowels in the English alphabet. So you may say that, sir, vowels in the English alphabet are 5. So this is clearly a finite set. This is a finite collection. This has limited elements. This has limited objects. But what if I ask you about the set of natural numbers? Sir, what do you mean by set of natural numbers? Look at the set of natural numbers. I'll reserve the capital letter N for it. So set of natural numbers will be given by 1, 2, 3, 4, 5, and so on, and so on. So I'm putting a dot, dot, dot kind of scenario here, which is denoting that this set over here is not something finite, it is infinite. Numbers are just keep coming, yes or no? Yes or no? So with this, I hope you are understanding the difference between a finite set and infinite set. And with this, I'd like to give you a classification of numbers as well, that initially, for the purpose of counting, what do we begin with? We begin with the set of natural numbers. What is the set or collection of natural numbers? As we have just discussed, 1, 2, 3, and so on. So the purpose of counting gets fulfilled with the natural numbers. But sir, what if I need 0? Let's say I don't have any money. So can I say that I have 0 money or 0 rupees? Yes. So 0 as a number gets introduced with whole numbers. So set of whole numbers is denoted by W, which has 0 also along with the natural numbers. So we believed or we thought that now we are complete. Whole numbers we have gotten. We have gotten all the doodle numbers, but gradually we realized that we need negative numbers as well. Sir, for example, I don't have, let's say anything, but what if I have something in minus? How can you have something in minus? Let's say you have taken 200 rupees from me. An amount of 200 rupees you have taken from me. So can I not say that you have minus 200 rupees? Why am I saying this? Because those 200 rupees which you have with you are not actually yours. So you're supposed to return those. So technically or mathematically, I could say that you have minus 200 rupees, which means we had natural numbers, we had whole numbers, and then with this, we brought the set of integers. So with the set of whole numbers, if I club all of the negative numbers, what do I get? Sir, will get the set of integers. So set of integers means all of these integers like minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on. So there comes a very beautiful classification which you all should understand, that here, all these numbers on the right of 0, like 1, 2, 3, 4, 5, they are positive integers. All the numbers on the left of 0, like minus 1, minus 2, minus 3, minus 4, they are called negative integers. So sir, what is 0? Always remember, students, 0 is neither positive nor negative. Exactly. 0 is neither negative nor positive. Don't say that 0 is both negative as well as positive. No. 0 takes or holds a neutral stand. So in this world of numbers, 0 is neither negative nor positive. Will you all remember that? If I extend it further, let's say that I go to a shop where I tell the shopkeeper that I want not exactly 2 kgs of rice, I want 2 kgs and 100 grams of rice. So where are we getting this 100 grams? It's like 2.1 kg rice. So 2.1. I think it is not there in this set, integer, whole or natural. So what is 2.1? So there I'm bringing fraction of a number. So I'm taking 2 kg plus 1/10 of another kg. Understanding my language, everyone? So that's where we got fractions. We got rational numbers. And set of rational numbers is given by Q. Now, so far, I was writing these numbers in what form? In roster form. Roster form means I was denoting all the elements. Now, this set of rational numbers, I'll be writing in the set builder form. Sir, what is set builder form? Set builder form says that Q contains elements. This set Q contains elements. Those elements are denoted by X, such that this X has following these two dots. These two dots are read as such that some books follow a straight line like this as well. So whichever you use, either two dots or a straight line, both are fine. So this set Q contains X such that X is a category of a number P by Q where or for all this inverted A reserves the meaning for the word for all. Just go ahead with the doubt, don't hesitate. So X is an element of this set of rational numbers such that x is given by p by q, x is given by p by q, where or for all p and q, for all p and q being integers, being integers. So this sign over here represents belongs to. This sign over here represents belongs to. Sir, what is Z? Either you write it as Z or I. The set of integers is denoted by either Z or I. Absolutely. I think that's exactly what I've just written, Mandakini, luckily or coincidentally. So what I'm saying is that here, rational numbers are given by what? They are taking a very, very, very beautiful definition here. That set of rational numbers, in this set builder form, I have written it. What did I all write? I wrote that Q, which means set of rational numbers, will contain elements x such that x will be a number of p by q form, where p and q are going to be the integers. Have I written it completely? Am I making any mistake? Did I do anything wrong here with this definition? Can somebody highlight the correction? Anyone in the comments? Am I not making a very small mistake here? Nobody's highlighting. That's very surprising. I hope some of you must have noticed that, sir, when you say P and Q belongs to the set of integers, you must have put one more condition, that here Q cannot be 0. Sir, when you talk about rational numbers, when you talk about fractions, you need to ensure that the denominator never becomes 0, because if this q approaches 0, or if this q becomes 0, this whole fraction will be going towards infinity. Getting my point, everyone? Comfortably understood this? Yes or no? So I hope natural numbers, whole numbers, then we got integers, and then we got rational numbers. So I think the story must end now. We have everything in the world now. I think what else do we need? I think the story is incomplete yet. Why? Because if I move further, I will notice that, sir, you will find some numbers which are, of course, of the form, let's say 1 by 2. There are some numbers which are of the form 1 by 3. So 1 by 2 is luckily that number which is 0.5. 1 by 3 is luckily that number which is 3. 0.3333333, infinitely this 3 is coming. So what is special about 0.5? So 0.5 is special in its sense where 0.5 is getting terminated. So this is a rational number which terminates, which ends. This is again a rational number which does not terminate, but it recurs, it repeats. So if I ever get a number which either gets terminated, or even if it doesn't terminate, it shows a repetition, it shows a pattern, I am okay with that. I will still call them rationals. I'll still call them fractions. But then, sir, what's the problem? What's the problem? I'll say, are you not noticing? Let's say if I give you a number, root 2, 1.414, and if you just keep exploring the value of root 2, you will keep seeing digits coming over here, digits coming over here. And the worst thing here happening over here is that these digits coming over here are neither repeating nor getting terminated, nor terminating. Shall I repeat this? Everybody got my point? What did I say? I said two things. These digits here are neither repeating nor getting terminated. Just give me 2 minutes. There is an important call. I have received it twice, so hold on for a while. I hope I'm clearly audible and visible, students. So there we are. I'm really sorry for the delay. I am saying that there are three categories of numbers. Which categories are? This thing here, that here, I am seeing that they got terminated. It terminates. After decimal, it terminates at a certain point. Yes or no? Sir, here, it wasn't terminating, but it was showing a recurrence. It was showing some pattern. It was showing me certain pattern here. Okay, that is also fine. But sir, what happened over here? The thing which happened over here is with the root 2, 1.41. And after this, digits keep on coming. The worst thing happening over here is that these digits neither repeat nor terminate, which means here there is no pattern over here. There is clearly no pattern over here. And the worst thing is it does not terminate. So how will you categorize it? Sir, this number and this number can still be written in P by Q form, but the problem here is that this number cannot be written in a P by Q form. So here this root 2 or any number which neither terminates nor repeats will be treated as an irrational number. So if the set of rational numbers were these, set of irrational numbers will be simply these. This root 2 here is a number which belongs to the set of irrational numbers. Got my point, everyone? What did I just say? That if we have this set of rational numbers, QC, the complement of Q will give me the set of irrational numbers. So whatever I've said so far is merely these are simple two things, which are I have set of rational numbers, I have set of irrational numbers. Set of rational numbers means technically the numbers which can be converted into a P by Q form. Set of irrational numbers, which means the numbers which cannot be converted into a P by Q form. Here, Q should not be 0. And my conclusion is pretty simple, that if you club all the rational and irrational numbers in the world, if you club all the rational and irrational numbers in the world, you are going to get the set of real numbers. Yes, if you plot it on the number scale, all the numbers between minus infinity to infinity, yes, will be called the real numbers. Now it contains everything. It contains integers, it contains natural numbers, it contains fractions, it contains irrational numbers, it contains everything. It does contain everything. I mean, this is a collection of all the real numbers, which means irrational and rational numbers. Getting it, everyone? So this is our set of real numbers. Now, set of real numbers is denoted by R, and this set is written as all the numbers between minus infinity to infinity. Now, sir, what is this? I'll explain it very soon. Have patience. But right now, what I'm trying to teach you is the concept of sets. Have you been able to understand the basic understanding of sets? Now, two things we want to understand here. Sets have two ways or versions. One of them is called the roster form. The second thing is called set builder form. Now, sir, what are these? Let's talk about them one by one. Roster form here says that if you can directly write the elements of the set, which means let's say there is a set A which has elements A, B, C, D and E. These are the 5 elements. These are the 5 elements. Excellent, sir. But what is the set builder form? Let's say I define one more set, set A here, which I give elements as 2, 4, 6, 8 and 10. So these are the 5 elements in this set A. Okay, sir. Excellent. Good. Now, this roster form here says that here it means that it has certain elements and you have specifically mentioned those elements. That's a way of representing or expressing sets. Sir, another way is set builder form. What is set builder form? Set builder form says that you say that A is a set which contains elements. So those elements I'm denoting by X such that, now such that this line or those dots are representing your such that. So this line over here represents such that X is an even number, or I can say X is equal to 2n. X is equal to 2n. X is equal to 2n. Where? For all. This means for all. So I need more space, so I will shift it a little so that it becomes more understandable. There I'll say for all n being natural numbers, for all n being natural numbers. So this sign here represents belongs to, and one more condition I'll impose, that I'll say n is less than equal to 5. Did you all get this definition or shall I repeat it? What did I just say? I'll explain it in a more detailed format so that set builder form is very well understood by everyone. Sir, what do you mean by set builder form? I said there is a set A which contains x such that x is equal to 2n, where or for all n beings natural number and this n is less than equal to 5. Sir, we are still not able to process it. What do you exactly mean by set builder form? Can you be more specific? Can you explain it in a more detailed format? Here you go. A contains x. Now what is x? X is 2n. Sir, what is 2n? 2n is 2n, which has a 2 and n. But sir, what is this n? This n is a natural number. Natural numbers like 1, 2, 3, 4, 5, 6, 7, no, stop at 5. So small n will take values like 1, 2, 3, 4, 5. So if I put n as 1, I'll get 2. So first value of x will be 2. If I put n as 2, 2 into 2 will be 4. Second value, n as 3, 3 into 2, 6. N as 4, 4 into 2, 8. N as 5, 5 into 2, 10. N as 6 will not be tried because here I am saying n is a natural number and n is less than equal to 5. So this and means this should be satisfied as well as this should also be satisfied. So I'll stop there and I'll say, yes, these are the elements of this set A. Give me a quick response in the comments if you all are able to process the set builder form and the set roster form. In this manner, I'm directly writing out all the elements. In this form, I'm defining all the elements through a method, through a definition. Any confusions, any queries, any concerns so far? Give me a quick response and update. Shall I go ahead from here, all the participants? Did you all get it? Everybody. Do you understand the difference now between set builder and roster form? For example, one more case we'll take. Let's say here I define a set X where I say it contains X such that X is the vowel of English alphabet. Yes or no? So this is one of the ways of writing a set X. Another way of writing the same set X will be what? Sir, vowels of English alphabet are A, E, I, O, U. So these are also the elements of this set. Comfortably understanding this, all the participants, the difference set builder form and set roster form. Are you all able to get it? Shall I move ahead from here? If you have been able to process it. Yes or no? With this, if I go ahead, let us talk about the empty set. So what is an empty set? If I talk about empty set specifically, empty set is given by this sign phi. This is a Greek letter phi. And empty set means if there is a set which does not have any elements. Let's say if I tell you that there is a set A which has elements x such that x is, let's say x is a prime number, x is a prime number between let's say 8 and 10. Now what will you say? Sir, between 8 and 10 there is one number which is 9 and 9 is not a prime. So what will you write here in this set A? I'll say set A contains no elements. So set A is going to be an empty set because there is no prime number between 8 and 10. Getting it, everyone? There are no prime numbers between 8 and 10, and that's why I'll say that x is going to be a prime number between 8 and 10. So there is no prime number. So how many elements will be there in the set A? No, nil, none. Which means set A is a null set. Set A is a null set. I can call it set A is a void set. I can call this set A is an empty set. Or in a better language, I could have called that this set A is phi. I could have called this set A to be phi. So phi in the world of mathematics does not mean 0. Don't misconfuse it with 0. Phi in the world of mathematics means nothing, null, empty void. I hope you understand the concept of space. This is my hand, this is another hand. Between these two hands, there is a space, there is void, there is a gap. So this is what do we mean by null, empty, void. Getting it, everyone? Understood the concept of empty set, yes or no? With this finite and infinite sets, as we have already covered, if I talk about the set of all the vowels, A, E, I, O, U, this contains limited elements. This contains countable elements. So this is called a finite set. But if I tell you or talk about the set of natural numbers 1, 2, 3, 4, 5 and so on until infinity, so that's clearly an example of infinite set which has elements which is taking you towards infinity. Yes or no? Everybody got it? Okay, so from here I'll go ahead. There we are. Everyone comfortably getting it? So far, is there any confusion? Can I move ahead from here, all the participants? Now, with this, the concept of subsets. This is the most interesting concept. Can you help me with the concept of subsets? Here, let's say I tell you that there is a class, and in your class, there are some students who like to play football. So, give me that set of students who play football from your class. Look at this statement. Understand this statement. What did I just say? I said you have your class, and in your class there are students. So let's say this expression here denotes the students of your class. So this is our class 11th. So in this class, I am categorizing students into three categories. One who like physics, other who like maths, and third who like chemistry. So there are students who like physics, there are students who like chemistry, there are students like who maths, and there are students who like none of these three subjects. Getting it, everyone? I hope you understood my statement. For example, there are two students A and B. There are two students A and B who like only physics. Yes or no? There are two students, let's say D and E, who like only chemistry. There is only one student F who like only maths. Understanding my language, everyone? Now let's say there is a student, let's say G, who likes physics and chemistry only. There is a student H who likes chemistry and maths only. There are, let's say, two students I and J. There are two students, let's say I and J, who like only physics and maths. And let's say there is one student, let's say, who likes all the three subjects, physics, chemistry, and maths. And there are few students like L, N, and let's say Q, they like none of these three subjects, neither physics, nor chemistry, nor maths. I hope this categorization makes complete sense. What did I just say? I said few things. For example, if I ask you, tell me the students who like only physics. What will you say? Sir, the students who like only physics are these, A and B. So these elements can be denoted by this A and B. Processing it, everyone, yes or no? Here, if I ask you the people who like only chemistry, what will be your response? Sir, it will be these two elements, D and E. What will be your response if I say or ask you the people who like only maths? What will you say? Sir, the people who like only maths is this guy F. So there is only one element, which is F. Yes or no? We also see that the number of people who like maths are always less. Not everyone can understand or make peace with it. So here, if I ask you one more statement, the people who like physics and chemistry, if I ask you the people who like physics and chemistry, what will be your response? Sir, who like physics and chemistry will be G and K. I hope you're understanding why am I taking K? Because K is clearly a person who likes physics and chemistry. But sir, K likes all three. But can I deny when somebody asks me, tell me whether K likes physics or chemistry or not, physics and chemistry or not? Yes, he does. So he'll qualify, yes or no? Getting my point, everyone? Now the next thing which I'm going to say is that can you help me with the people who like only physics and chemistry? There, K will not be there. I need a person who likes only physics and chemistry. So in your class, the person who likes only physics and chemistry is this person who is G. Able to make some sense out of it? I'll repeat. Here I'm concluding few more things. For example, if I ask you the people who like chemistry and maths, can you help me with the people who like chemistry and math? Sir, chemistry and math is liked by H and K, these two persons. But if I ask you only chemistry and math, then what will you say? Sir, in that case, this is H because K likes physics as well. I hope you're understanding the difference, everyone. Similarly, if I ask you the people who like physics and maths, the people who like physics and maths, so what will be your response? Sir, physics and maths is liked by I, J, K. There are three people. So I, J, K. These are the three people who like physics and math. Now, again, if I put only physics and math, what will be your response? Sir, in that case, this K is somebody who likes chemistry as well. So only physics and math will be liked by I and J only. Now, one more question if I ask you that there is a person who likes physics as well as chemistry as well as maths. The person who likes all the three subjects, who's that person? So there is only one person, that is K. Everybody understood this idea. And can you help me the people who like none of these subjects? None of these subjects. There are people who like none of these subjects. There are L and NQ. These are the students who like none of these subjects. Yes or no? And let's say your class 11th set is denoted by U. So U set has how many elements? Sir, set U has elements A, B, D, E, F. A, B, D, E, F. Yes or no? Then after this, I have G, H, I, J. After that, I have G, H, I, J. And after that, I have K, L, N, Q. After that, I have K, L, N, Q. So that's your class. I repeat, this set U is your class 11th. And all these sets are derived from your class 11th. So technically, all these sets, like the people who like none of the subjects, the people who like exactly one of the subjects, the people who like exactly two of the subjects, or at least two subjects, or the people who like all the three subjects, all these sets are called the subsets. Able to digest the meaning of the word subsets, everybody, or shall I repeat it? The meaning of the word subsets. What is a subset? Subset means from a set, if you fetch some elements, then that set or collection will be called a subset. Getting it or not? For example, here, let's say, there's something wrong with the board today. Let's say I have a set which has elements 1, 2, and 3. I have these three elements in this set X. Now help me with all the subsets of this set X. So sir, I'll say if I take 1 only, it will be a subset. Because from this set, I have chosen some elements, so I have chosen 1 alone. Or if I take 2 only, that's a subset. If I take 3 only, that's a subset. If I take 1 and 2, that's a subset. If I take 2 and 3, that's a subset. If I take 1 and 3, that's a subset. Sir, what if I take all three? Yes, it is still a subset. Why? Because from this set, I just need to choose some elements. If I have done that, it's called a subset. The story doesn't stop here. Don't you think that if I choose nothing, that's also a subset? It's like you're going to a party. You're going to a party, and there in the party, you have 3 dishes: first, second, and third. So in how many ways can you feed yourself? Sir, I eat only the first dish, or I eat the second dish only, or I take the third dish only, or I may take first and second dish, or second and third dish, or first and third dish, or I may take all 3 dishes, 1, 2, 3, or I may don't eat anything at all. So these are the ways in which I can feed myself in a party. These are the ways in which I can feed myself in the party. So these all are the subsets of X. And these are going to be the total subsets of X. Sir, what do you mean by that? This means that you won't be having any other subsets apart from these sets of X. I said X will have these as its subsets. If I calculate the number of subsets, I will say it is 1, 2, 3, 4, 5, 6, 7, 8. So number of subsets are 8 here. Sir, can we generalize it? Yes, we can. Either you use permutation and combination or binomial theorem. Neither of you know right now at this stage. But if I could directly give you the formula, that here if there is a set X and you need to calculate number of subsets of X, then you simply give it by 2 raised to the power number of elements in X. Now this thing here, number of elements in X is called cardinal number of X. Number of elements in X is called, this thing over here is called cardinal number of X. So here I am saying this thing repeatedly, that if I am told 2 to the power nx, so nx here means cardinal number of X. Sir, what is cardinal number of X? Cardinal number of X is nothing but number of elements in X. So how many elements are there in X? Sir, there are 3 elements in X. So if there are 3 elements in X, number of subsets of X are going to be 2 to the power 3, which is 8. Everybody understood it? Everybody got it? Or shall I re-explain this? The concept of subsets, are you able to process? Yes or no? Everybody. Sir, how did you get it? That I'll explain in our regular batches. Here is the one shot, so I'll keep it to the point. I'll not go much into the derivations, but I'll keep it to the point. Everybody got it? Shall I re-explain this idea? Let me take you through the concept of power set as well in this slide only. First of all, are you all comfortable with the concept of number of subsets? Yes or no? The concept of subsets. If I do one thing, sir, what one thing? If I club all these sets, sir, what are you saying? I am saying that can I create a set of sets? What did I just say? That can I create a set of sets? Yes, I can. So if I create one more set which contains all the subsets of X. So this is a set which contains all the subsets of X. What is this? This here is a set of all the subsets of X. So this set over here, which contains all the subsets of X, is called power set of X. It is called power set of X. So whether you write power set of X or set of all subsets of X, it is same. Give me a quick response in the comments. Are you all able to understand this? Are you able to get this meaning? What is power set of X? Now, one more thing I'd like to ask you. Can you help me with the cardinal number of power set of X? So what did you just say? I said number of elements in power set of X. Number of elements in power set of X. So what am I asking you is, I'm asking you the cardinal number of this set Px. Yes or no? What is Px? Power set of X. So what do we mean by power set of X? Sir, power set of X, cardinal number means that number of elements in power set of X. Cardinal number means number of elements. But sir, what is power set of X? Power set of X means the set of subsets of X. So what are they asking? They are asking you the total number of subsets of X. And I think we know that. We know that. How do we calculate it? The total number of subsets of X. We have developed a formula 2 to the power number of elements in X, or 2 to the power cardinal number of X, and which was 3. So it will be 2 cube, which will give you 8. And I think we have already evaluated it. But did you all understand it? Does it make complete sense? Are you able to process it? Yes or no? Yes or no? This and this are absolutely same. I hope you wouldn't forget it now. Got it, everyone? Now, sir, equal set, equality of sets. When do we call two sets to be equal? When do we call two sets to be equal? Let's say there is a set A, which contains elements like 1, 2, 3, 4, 5. There is a set B, which I'm defining as X, such that X is a natural number and X is less than equal to 5. Now you tell me what will be there in set B. Can you help me with the roster form of set B? I hope you're understanding. This set A is technically written in set builder form, roster form, because here I have given the elements specifically or directly. But here in this case set B, I hope you're realizing set B contains X such that x is a natural number and x is a natural number less than equal to 5. Is it not the set builder form? Yes, sir, it is the set builder form. So in the set builder form, what do we see? Sir, in the set builder form, we clearly say that x is a natural number. So natural numbers like what? Natural numbers like, sir, 1, 2, 3, and so on. Sir, will I keep writing it? No, you stop at 5. So you write all the natural numbers till 5. So 1, 2, 3, 4, 5. So look at these two sets, set A and set B. Set A and set B. Can you help me with these two sets? Sir, yes, we are noticing that set A and set B have the same number of elements and those elements are absolutely identical. Those elements are absolutely identical and hence I'll say that set A and set B are equal. So did you understand the concept of equality of sets? And yes, in sets, remember this as a fact that let's say there is a set Y which is given by, let's say, 1, 2, 1, 3, 4, 5. So it does not make any sense to repeat an element in sets. If you're writing elements in the roster form, if you're representing the set in the roster form, you don't consider the elements which are getting repeated, which means it's a bad practice. Preferably, I'll write Y as 1. So this one is getting repeated. I'll remove it and I'll write all the elements uniquely at once. And again, I would see that this set Y has also the same number of elements and the elements are identical with A and B. So set A, set B and set C are, set Y are equal sets. Did you all get it? Comfortably, all the participants? Shall I move ahead from here if you have understood this concept? Now, let's talk about intervals. Shall we, everyone? Now, pay attention, everyone. This is the most crucial part, which we'll be using almost everywhere in your 11th class and 12th class. Almost in every single second or third question. So pay attention, everyone. Stay alert. This is something really crucial and important, which you must not forget. Everybody paying attention here to this part. Now, what does it say? It says intervals. Let's say if I ask you to solve an equation, an inequation. Sir, what do you mean by inequation? Inequation here means, let's say if I ask you to solve 2x minus 3 greater than equal to 0. First of all, sir, this is not an equation. It is inequality. It is an inequation. So less than, greater than, less than equal to, greater than equal to, not equal to are inequations or inequalities. So there, how do you do it? I can add a 3 on both the sides. So it will become 2x greater than equal to 3. I can divide both the sides by plus 2. So I hope you remember, if an inequality or an equation is divided by a positive number, the sign of the inequation doesn't change. So if I divide both the sides by 2, x will be greater than equal to 3 by 2. Now this is a way of representing it or understanding it. This is a very good way. But another way of representing the same idea could be this, that sir, on the number scale, there is a number minus infinity, there is a number plus infinity, and there is a number 3 by 2. So this is where I'm seeing 3 by 2. So how do we represent this x? I'll say this x can be taken as that you are taking 3 by 2 or all the numbers greater than 3 by 2, which means x can be either 3 by 2 or any number greater than 3 by 2. 3 by 2 is approximate or exactly 1.5, 1.5, 1.55, 1.56, 1.57, 2, 3, 3.2, 3.8, 4, 5, 6, 7, 8, 9, 10 until infinity. All of these numbers will satisfy our inequality. So sir, either you write it like this, which is one of the ways of representing your solution of this inequality, or this number line method, which I'll be using at a lot many times. And more importantly, are you able to make some sense out of this part, this solid circle? So I'm putting a solid circle over 3 by 2, which means 3 by 2 is included, or any number greater than 3 by 2 should be considered as a solution for this inequality. Sir, can there be some other method as well? There is indeed. What is that method? So I can write it as x belongs to, this sign here represents belongs to all the numbers between 3 by 2 to infinity. All the numbers between 3 by 2 to infinity. All the numbers between 3 by 2 to infinity is given by 3 by 2 comma infinity. But how do I represent or say that 3 by 2 is included or excluded? Here in this case, it is included. So I'll use this parenthesis. So this parenthesis sign over here, is called closed interval. So if I put a parenthesis over here, it means 3 by 2 is included. But I hope you do understand that infinity is never included. So I'll use this small bracket, and this small bracket here is called open interval. I know some of you are confused. Let me clarify this. Let's say I want to talk about all the numbers between 2 to 7, but I don't want to include 2 and 7. I mean, 2 should not be there, but 2.0001, 2.1, 2.3, 2.5 till 6.8, 6.9, 6.999, 6.98, all of these numbers should be there, but 2 and 7 should not be there. So how do I represent it? So over 2 and 7, I have used hollow circles. So these circles are making me understand that there is a number x, which lies totally between 2 and 7. So either this way of representation is there or this way of representation is there. So do we have some other way? Yes, there is third approach as well, which says that x is a number which belongs to. I hope this sign is very well understood by you all. This sign here says x belongs to which set? Sir, x takes all the numbers between 2 to 7. So I'll write it as 2 comma 7. But you tell me, am I supposed to include 2 and 7? No. So if I'm not supposed to include 2 and 7, I'll use open interval. So this open bracket here makes us understand that 2 and 7 are not included. They are excluded. Got my point, yes or no? Or shall I repeat it? All the participants. Everybody comfortably getting it? Can I move ahead from here? Sir, instead of this, let's say, what if we are given a scenario where this is the number line. On the number line, this is -3, this is 10, and you are supposed to take all the numbers between -3 and 10, including these two, which means here I'm told that x is a number which is taking any number between -3 and 10, including -3 and 10. Then how do we write it? So this is the number line method. This is simple inequality expression based method. Now, do we have interval method? Yes. I'll again say that x is a number which belongs to the set of all the real numbers between -3 and 10. So I will write this as -3 comma 10. Sir, shall I include -3? Yes. So inclusion means closed interval. Exclusion means open interval. Sir, shall I include 10? Yes. So I'll use closed interval. So I repeat, this bracket here is called open interval. And this parenthesis big bracket here is called closed interval. More importantly, instead of their names, are you understanding their applications? How are we using them? How are they getting utilized? Everybody comfortably? Yes or no? Give me a quick response in the comments. Everybody got this point? So far, are there any confusions? Any clarity you need? Please ask. Shall I move ahead from here? Sir, do you mind talking about a few more things in detail? Which things, students? Let's say I ask you or give you another scenario where I say that x is a number which takes all the values from -2 to 7. So on the number scale, how will I plot it? I'll say x is a number from -2 to 7, -2 excluded, 7 included. Now you tell me how will you write it in the interval form. So in the interval form, I'll say, sir, x is a number which belongs to all the numbers between -2 to 7, but -2 excluded, 7 included. So open closed interval. You may call it semi-open, you may call it semi-closed, but I hope more importantly, their names, you are understanding their process, the flow. Yes or no? Similarly, one last case I'd like to discuss with you. There, let's say if I say that x is a number which takes all the numbers from 3 to, let's say, 55. So on the number line, how will I plot it? So there is a number 3, there is a number 55. 3 is included, 55 is excluded. So this is the number line representation. This is inequality based, expression based approach. So if I wish to write it in form of interval method, I'll say, sir, take all the real numbers between 3 to 55. So all the real numbers between 3 to 55 are given by 3 comma 55. Now tell me, 3 included, close. 55 excluded, open. Does it make complete sense? Are you able to comprehend it comfortably? Are you able to get it? Yes or no? So did you all understand the concept of intervals first of all? Yes or no? With the concept of intervals, I'd quickly tell you some basics of inequalities as well, so that whenever we solve them, you never get confused. So with inequalities, let's say if I'm solving 2x plus 3 greater than equal to 5. So you may think that sir 3 is going there and becoming minus 3. That's a good approach or way of thinking it. But technically what we do is we subtract a fixed number from both the sides. So that's how we say 2x is greater than equal to 2. Now one more thing we do is we are now going to divide both the sides by plus 2. What if this was minus 2x plus 3 is greater than equal to 5? Then what will you do? Sir, to get rid of this minus 2, I would have divided both these sides by minus 2. Now always remember, in inequality, when you multiply or divide them by a negative number, the sign of the inequality changes. What did I say? I said sign of the inequality changes if both of the sides are multiplied or divided, you can call it multiplied as well, by a negative number. Did you all process it? Did you all get it? Which means what? So to get rid of this minus 2, I'll divide both the sides by minus 2. So minus 2 by minus 2 is plus 1. 2 by minus 2 is minus 1. But pay attention everyone, the only mistake which we are committing here is that sir greater than equal to will get converted into less than equal to. Did you get it? And why did it happen? All because of this property, which I'm sure you wouldn't forget now. Will you all remember it? All the participants. So this is something very crucial which you need to remember as an IDJ aspirant, as a class 12th aspirant here while applying inequalities. Now, one more thing I'd like to tell you here is something really crucial and important, that let's say this is a way of writing x. Sir, can I represent it on the number line? Yes, we can. How? So to represent it on the number line, I could have used this number scale. All the numbers from minus infinity to infinity, there will be a number minus 1. Sir, minus 1 included all the numbers which are less than minus 1. So this is a way of writing it. Do we have any other approach? Do we have any other method? Yes, we do have. What is that method? Can I say x belongs to the set of all the numbers between minus infinity and minus 1? So how do we write it? Between minus infinity and minus 1, these are all the numbers. With the comma, I separate them. But minus infinity and plus infinity are never included. So open interval. But minus 1 is closed because it has to be kept. It has to be included. It has to be considered. Everybody got my point? The concept of intervals, are you all able to process? Yes or no? I think power sets I have already explained, but if you still want more clarity on it, I'll make you go through it one more time. Let's say there is a set Y which contains elements 1 and 2. Let's say you go to a party where you are given 2 dishes. Which 2 dishes? Let's say upama and dosa. Now, in how many ways can I feed myself? I'll say, sir, in that party, I have a choice to not eat anything. So having nothing means what? In mathematical world, I'll say 5. Or I could have eaten only upma. I could have eaten only dosa. Or I'll prefer to eat both. Why should I not? If I can, why should I not? So this set of all the subsets. What are these sets? This phi, only U, only D, U and D. These are the subsets. So if I create a set of all the subsets, this is called the power set. This is called the power set. So what is power set here, students? Power set is the set of all the subsets of a given set. Everybody understood it? Do you need more clarity on it, or have you all understood it? Yes or no? All the participants got my point comfortably? With this, one more thing, very interesting thing comes here into picture, which is, what if I ask you the number of subsets? As we have already discussed, number of subsets means number of elements in power set of A. Sir, it is clearly visible 4. But if number of elements in Y are more or high, then how will I crack it? I'll say the very simple idea. It is given by 2 to the power number of elements in the set whose subsets I'm trying to count. So number of elements in Y are 2. So it will be 2 to the power 2, which is going to be 4. So there will be 4 elements in the power set of, not A, I'm really sorry. Nobody corrected me. Why? It will be power set of Y. Yes or no? All the participants, everybody got it? Comfortably understood it? Any confusion, query or concern so far regarding anything? Shall I move ahead from here? Did you all get it completely, totally and thoroughly? With the concept of power set, let's go to the concept of universal set. Let's say again, I take you to the concept of universal set with this statement where I say that let's say this is a set, which I'm calling universal set. So let's say in this universal set, I am writing all the students of our class. I'm writing all the students of our class. Now I categorize you based on two categories where I say some students like Upma and some students like Dosa. So I'm categorizing students of our class into two categories, whether you like Upma or you like Dosa. So if I classify students of our class into these two categories, I hope you're realizing there are not merely two categories, there are actually four categories. Sir, what do you mean by four categories? Are you clearly not noticing that which four categories I'm talking about is that here, this region, if I could shade out this region over here, what does it represent? This region here represents the people who like only Upma or Upma only. Yes or no? If I shade this region over here, what does this represent? This shaded region over here represents the people who like only dosa or dosa only. What about this region, which I shade out here? This region represents those people who like upma as well as dosa. So this is reserved by people who like upma and dosa. Mind you, students, I'm specifically and deliberately and intentionally using a word time and again and. So I hope some of you must have been able to process the meaning of this word and. The story doesn't stop here. There is one more set or one more classification where I'll say outer of this upma and dosa or upma or dosa, this region. Can you interpret this region? What does this represent? Sir, this region over here represents people who like neither upma nor dosa. So if somebody likes neither upma nor dosa, it means they like neither of the two items, they'll be pushed outside these two sets. So all this discussion I had when I wished to classify the students of our class, whether you like upma or not, whether you like dosa or not, whether you like both or not, or whether you like neither of them not, I had to consider a frame of reference. I was talking with respect to a fixed set. So that fixed set is called the universal set. So with respect to a bigger set, a complete set, I'll be having a discussion. Got my point, everyone? Or shall I tell you this thing again? Everybody with me so far? Any queries or confusions? Yes or no? I repeat, what did I just say? These four things, do they make complete sense? Are you getting it? So first of all, I'll take you through the concept of universal set one more time. Let's say if I have all the natural numbers, if I have all the natural numbers, if I have all the natural numbers. So this is the set of all the natural numbers. So set of natural numbers, let's say I want to divide into different cases. Which kind of different cases? Let's say there is a set which is the set of all the prime numbers. There is a set which is the set of all the composite numbers. And I hope you do realize there is no number in the world which is prime as well as composite. Which means, let's say if I ask you prime numbers like 2, 3, 5, 7, 11 and so on. Composite means what? Composite means 4. You will have then what? 6, then 8, 9 and so on. So what about 1 in that case? I hope you do realize 1 is a unique number which is neither prime nor composite. So 1 will stay out of these two sets. So this whole discussion where I'm talking about 1 or prime numbers or composite numbers with respect to certain set of numbers which is called the natural numbers. So here this set of natural numbers will be treated as universal set, and based on that I'm coming up with different conclusions. Everybody got my point? Any queries or confusions? If there are, please ask. Shall we move ahead from here? Are there any doubts, queries or concerns? Please ask if you have any queries, concerns or doubts. We'll definitely address them. With this discussion, I'll talk about Venn diagrams. Technically, I have already introduced Venn diagrams. Did you notice them? The squares, circles, all those were nothing but what? The Venn diagrams. I'll show it to you one more time for the sake of giving more clarity. So let's say here we have a universal set. Here we have a universal set. right? Yes or no? And in this set, I am defining few more sets. For example, this one, and then the other one, let's say like this, and then one more here, like this. So these are the different sets I have taken. Let's say the same classification I do here. The same classification I do. Let's say this is the set of people who like physics, people who like chemistry, people who like maths. So if I could highlight different regions, just give me a moment. If I could highlight different regions, how will I highlight? Pay attention, everyone. And I'll try and explain Venn diagrams. Venn was, I think, a mathematician who developed this method of representing sets with the help of Venn diagram. So if I ask you the people who like physics, so which region here will denote people who like physics? I hope nobody is thinking or saying that, sir, this region is telling you the people who like physics. No, that's wrong. If you are highlighting this region as the region which will be giving you me idea about the people who like physics, then it is wrong. This region is giving you the idea of people who like only physics. What did I ask you? Did I ask you only physics? No, I asked you people who like physics. So if I approach this region, they like chemistry as well, but do they not like physics? If I approach this region, they like maths as well, but do they not like physics? If I approach this region, they like chemistry and maths as well, but do they not like physics? Yes, they do. So if I'm asked about the people who like physics, what will I say? Sir, if you are asked about the region needed to be shaded by the people who like physics, I'll say this region will say people who like physics. But are you understanding the difference? If I ask you, highlight the region where you are highlighting the people who like only physics. So these should be the students who don't like any other subject. They should like physics only. So which region will you shade now? So people who like physics only will be given by this. Makes complete sense? Is it understandable? Are you able to digest all what is being said without any confusion? Similarly, what if I ask you the people who like chemistry? What will you say? Sir, people who like chemistry would mean this entire region now. Yes or no? This entire region now. And I hope if I ask you the people who like only chemistry, in that case, what will you say? Sir, only chemistry will be this portion. Similarly, what if I ask you maths? So, sir, people who like maths would be this region. But if I ask you people who like only maths would be given by which region, students? This. The people who like only maths will be given by this region. Comfortably able to process this idea? Yes or no? With this, what if I ask you, tell me people who like physics and maths. Tell me the people who like physics and maths. I'm using a conjunction specifically here, which I'm denoting by the word and. Please pay attention, everyone. Now it plays a very crucial role in drawing Venn diagrams here. Conjunctions and or play a really crucial role in Venn diagrams. Physics and maths. So I'm looking for those students who like physics as well as maths. Where do they lie? I hope you are clearly noticing that people who like physics as well as maths are these ones. Did you all get it? Did you all understand it? But what if I ask you to find out people who like only physics and maths? In that case, what will you say? Sir, I am coming to your class now and I'm asking a question that kindly stand up all those people who like only physics and maths. Now, if you like chemistry, you should not stand. So in this case, will I shade out this region? No. These are the people who like physics and maths, but they like chemistry as well. I don't need them. I am looking for the people who like physics and maths only. So if I'm looking for the people who like physics and maths only, I'll be highlighting this region. Are you understanding the meanings of these words? How do we interpret them? Yes or no? Now my next question. Tell me the people who like physics or chemistry. Let's say I come to your class and I ask you, all the people who like either physics or chemistry, kindly stand up. So who all will get up? Sir, anybody who likes physics only will definitely get up. Anybody who likes physics only will get up. Anybody who likes chemistry only will get up. Yes or no? Anybody who likes physics only will get up. Anybody who likes chemistry only will get up. And somebody who likes both physics and chemistry will also get up. What was my question when I entered into your class? I said, everybody who likes either physics or chemistry, kindly stand up. So anybody who likes physics or chemistry will get up. So are you able to process the meaning of the word or? Or means what? Or means only physics is fine, only chemistry is fine, and even physics and chemistry is also fine. Let's forget set of maths for a while. Let's not bring it here to confuse you unnecessarily here. Let's say maths set does not exist here in this case. I'm talking with respect to the set of physics and chemistry only in this case. So there I'm asking you, tell me the people who like physics or chemistry. So I'll say physics or chemistry would mean the people who like only physics, or the people who like only chemistry, or the people who like physics as well as chemistry. Are you understanding this meaning, yes or no? So what does it mean? It means that either physics or chemistry. So either physics or chemistry does not mean physics only or chemistry only. No, it means only physics or only chemistry or both. I'm putting a word here, or both. What I'm trying to say here is a very crucial fact. Please pay attention, everyone. Let us say that I have a set which contains two subsets. Let's say this is the people who like cricket. This is the set which is reserved for the people who like football. So these are the people who like cricket. These are the people who like to play football. Let's say in your class, there are a certain number of students, out of which 10 students like cricket, 15 students like football, and 5 students are there who like both cricket and football. What if I ask you to tell me the total number of people who like either cricket or football? What will be your answer? So in that case, I'll say number of people who like cricket plus number of people who like football. So number of people who like cricket would be how much? Can you help me with that? The number of people who like cricket would be 15, because this 10 plus 5 will be the 15, yes or no? So number of people who like cricket would be 10 plus 5. Getting it, everyone? Sir, the number of people who like football, will be this, which is 15 plus 5, yes or no? So number of people who like football will be 15 plus 5, which is going to be how much? Which is going to be 10 plus 5, 15, 15 plus 15, 30, 30 plus 5 is 35. So technically you're saying there are 35 people in your class who like either cricket or football. Let's calculate it manually. I think we are making a mistake. Can somebody highlight that mistake in the comments? I'll really appreciate it. I hope some of you must have realized. So total number of people who like either cricket or football are 10 plus 5, 15 plus 15, 30. So if you are saying or asking us to calculate the number of people who like either cricket or football, then I think the answer will be 30. But when you did this, number of people who like cricket or football, by simply adding the number of people who like cricket with number of people who like football, I think I am making a mistake. Can somebody in the comments tell me what mistake I am committing here? Anybody. I hope you are clearly realizing that, sir, the only problem is that you are making a mistake by calculating this 5 twice. These 5 students are those special students who like cricket as well as football. So when I count the number of people who like cricket, these 5 get added. Yes, fine. But when I calculate the number of people who like football, these 5 people will get added twice. I hope you are noticing it. But they were supposed to be counted only once. So I made a mistake. What mistake? I counted these people who are there common in both, are getting counted twice. So I need to reject them from either of the places. Yes or no? So what will I say when I wish to talk about number of people who like cricket or football? I will give this data by number of people who like cricket or number of people who like football. But from this, I'll subtract the number of people who play cricket and football both. Getting it or not? Yes or no? So I said, to get the exact data of people who like either cricket or football, I'll say from this 10 plus 5 plus 15 plus 5, I need to subtract this 5. Now what is this 5? This 5 over here This 5 over here is called intersection, common part. So this intersection is denoted by C inverted U F, intersection of cricket and football. What did I say? I said two things. Which two things, sir? If I have two sets, so I can perform certain operations on those sets. So what kind of operations can you perform? Let's say there is a set A, there is a set B. So whenever I mention the word A or B, so mathematically it is written as A union B. It is given by A union B. So what is A union B? A union B means A only, it means B only, and it means A and B both. So this shaded region represents A union B. But if I ask you A intersection B, A intersection B, so this is set A, this is set B. A intersection B is given by A and B. It is given by A and B. So what does it mean? It is given by the sign A inverted U B. So this sign U is reserved for the operation union. This inverted U sign is reserved for the operation intersection. So what is intersection here? Intersection means the common portion between A and B. So first of all, are these two operations very well understood by you all? Union and intersection. Union we reserve or denote by the word or. Intersection we denote by the word and. For union, the reserved symbol is this U, and for intersection, the reserved symbol is this inverted U. Which means if I come back to this formula and try and teach you this formula over here, I hope you're getting it. Number of elements in cricket, the people who like cricket are 10 plus 5. The number of people who like football are 5 plus 15. But this 5, which is getting counted twice, doubled, should be subtracted once so that equation stays balanced. So C and F have something in common, which is 5, because when I calculated C, when I calculated F, it got counted twice. So what I'll do is I'll subtract this intersection. And what does it finally give me? It gives me C union F. It gives me the people who like cricket or football, which means this number is now going to be 15 plus 20, 35 minus 5 is 30. Now I see the data to be in sync. Now we see or claim that yes, data is sorted, data is organized. So are you realizing how are we generating this formula? How is this formula getting derived? Yes or no? So finally, if I could relate union and intersection for two sets, how will I do it? Everybody, please pay attention. I'm going to do something very interesting. I'm hoping that you all pay attention. Let's say if I calculate NA union B, if I wish to calculate NA union B, so it will be given by number of elements in A plus number of elements in B minus number of elements in A and B. That's how you write the formula for A union B. Any confusion so far? I was trying to explain the concept of Venn diagrams, but I got carried away and I explained the concept of intersection as well. Because in Venn diagrams, we need intersections. So what do you really mean by that? Let's say if I ask you, kindly help me with the people who like physics and maths. What will you say? Sir, physics and maths, if you wish to highlight in Venn diagrams, this region here will give you physics and maths, which means what? Which means you are saying intersection of physics and maths. Simple, clear, yes or no? But what if I ask you to highlight the region only physics and maths? What will you say then? So now I need to consider the people who like only physics and maths. They should not like any other third subject. So in that case, this region over here will give me the part or the students who like only physics and maths. Everyone comfortable with whatever I've done so far? Any queries or concerns? Please ask if there are any doubts. Otherwise, we'll move ahead. All the participants understanding it comfortably without any queries or confusions. Shall I move ahead from here? All the participants, yes or no? Everybody getting it? With this, if I could move ahead with more clarity on these different things. Let's say, what if I ask you, tell me the people who like physics or chemistry but not maths. then how will you highlight this region? The people who like physics or chemistry but not maths, how will you highlight this region? Will you all not say that, sir, in that case, what are we going to do is, you want physics or chemistry. So what is or? Sir, or means union. Or means union. So or means union what? Physics or chemistry would mean union of physics and chemistry. So this is that region. But sir, you highlighted one more thing, but not maths. But not maths. So should you not remove this part where you have mistakenly taken maths? Yes or no? So this region over here, which is either physics or chemistry, but not math, is this. Absolutely, Moksh. I'm glad you highlighted it. That's brilliant. Keep it up. Keep it up. I hope everybody is able to process this idea. Whole thing, whatever we have done so far. Any queries or confusions regarding this? Shall I move ahead from here? With this, let me ask you a few more questions. What if I now ask you that physics and chemistry, but not maths? What will be your response in that case? Now, the moment you see physics and chemistry, okay, physics and chemistry means what? Physics and chemistry. So, sir, this is physics and chemistry. But, sir, you said not maths. So, if you're saying not maths, exclude this part. So, this portion, physics and chemistry only, is representing that region. So, are you able to make some sense out of the Venn diagrams? Yes or no? How do we represent sets? How do we define regions? Did you all get it? Or is there any confusion on that? Everybody comfortably got it. Now, on sets, we perform certain operations. So, what kind of operations? Different operations we perform. For example, there is a set A. Let's say it is given by 1, 2, 3, 4. There is a set B, which is given by 2, 4, 5, and 7. Now, if I define the operation union, if I define the operation intersection, if I define the operation difference, if I define the operation symmetric difference, they all are operations. Sir, but exactly what are they? What do they mean? Let's talk about them one after another. Let's talk about them one after another. Let's say we are talking about union. We are talking about union. So let's say there is a set A, there is a set B. Set A has certain elements, for example, 1, 2, 3, 4. Set B has elements, let's say 3, 4, 5, 6. Yes or no? Everybody got it. If I were writing it in a roster form, this is the Venn diagram representation. Set A, I would have written as what? I would have written as 1, 2, 3, 4. Yes or no? Set B, I would have written as what? I would have written it as 3, 4, 5, 6. Yes or no? I think 4 I have mistakenly written at both the places. I made a mistake. Nobody highlighted it. That's very unfortunate. 4 would be here. Yes or no? 4 was there in both. So B will be written as 3, 4, 5, 6. Everybody getting it? Now you tell me one thing. Can you help me with A union B? Sir, what is union? Do you remember union? Union with respect to two sets will be given by the region where only A belongs, the region to only B belongs, and the region which is belonged by A and B both. So technically A union B means this whole. But sets have their constraints that every single element should be counted only once. That's good, Moksh. So with this, what will I conclude now? I'll be saying that A union B will be 1, 2, 3, 4. 3, 4 is common, so I'll not write it twice. So I'll say 1, 2, 3, 4, 5, and 6. That's A union B. Everybody comfortably got it, or are there any confusions? Please ask if there are any. What about intersection, students? How do we define intersection? So if I wish to get into intersection, what will I do or say here? In terms of intersection, again, I'll take this simple idea here. Let's say there is a set A, there is a set B. Set A has elements 1, 2, 3, 4. Set B has elements 3, 4, 5, 6. The same idea here. Now, if I wish to figure out A intersection B, intersection is given by this sign. So what is intersection over here? Sir, intersection means the region which is common to A and B both. So the region which is common to A and B both contains these two elements 3 and 4. So A intersection B will be given by 3, 4. First of all, are you able to highlight the union part. This thing over here is union. And this thing over here is the intersection. It's Moksha. Okay, I'm really sorry, Moksha. Sincerest apologies for mispronouncing your name. I'm really sorry for that. Now let's talk about difference of sets. What do we mean by difference of sets? Let's say again there is a set A, there is set B. This is set A, this is set B. Set A contains elements like 1, 2, 3, 4. Set B contains elements like 3, 4, 5, 6. Now, what is A minus B? Let's talk about A minus B now. This minus sign is called difference of sets. So A minus B would mean take all of A, but from it remove the part of A which is common with B. What did I say? Take whole of A. So what is whole of A? Sir, A had these elements 1, 2, 3, 4. A had these elements 1, 2, 3, 4. But out of these elements, there were elements which were common with B. Which elements? 3 and 4. So simply remove them. So technically A minus B will be given by 1, 2. Shall I repeat that part or everybody processed it comfortably? Yes or no, all the participants? Shall I do it again? What did I just say? I am saying A minus B here. A minus B here is given by this region. What is the meaning of this region? This region means from set A, if I remove the part of A which is common with B, then I'll be left with only A, and that's A minus B. On the basis of it, can you help me in cracking B minus A? I hope you all would realize and accept that, sir, B minus A will be a totally different story. Why? Let's say this here is a set A, this here is a set B. Set A has 1, 2, 3, 4, 5, 6 like this. Now, what if I ask you B minus A? Sir, B minus A would mean that you take B, but from B, you remove the portion which is common of B with A. Able to process this definition first of all. So, B I take will give me 3, 4, 5, 6. But from this, if I remove the portion which is common with A, so common with A means 3 and 4 are to be removed. So B minus A would technically be given by these elements 5 and 6. That's good, Moksha. So this region over here is representing B minus A. Did you all comfortably understand the concept of difference of sets? Yes or no, all the participants? Shall I move ahead from here if you all get it? What is the complement of a set? What is the complement of a set? Let's say these are all the alphabets. So all the alphabets are denoted by, let's say, A. And here, let's say I have a set of all the vowels. So this is set of all the vowels like A, E, I, O, U. Yes or no? So outside of this vowel and inside this alphabet, I'll see B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, Z. I hope I did not write anything additionally or mistakenly. A, E, I, O, U should be splitted. So A I did not take, E I did not take, I did not take, O I did not take, U I did not take, right? So this is the set V. This is the set V. This set over here is the set V. And this over here is the set A. Getting it, everyone? Now, pay attention, everyone. This A here in this context is going to be called what? R universal set. This A here in this context is going to be called what? R universal set. Yes or no? And this V is simply a set. And in this context, I would call V to be a subset of A. So the sign of subset is given by this C kind of a sign. I forgot mentioning it previously, but I hope it makes complete sense even if we do understand it now. Now, here I'm trying to tell you that what if I ask you complement of V? So V complement is given by VC or V dash or V bar, depending on the books you're following. But here I'm saying that what is the complement of V? So complement of a set means with respect to a universal set, we see complement of a set as that from this universal set, if I remove this V, whatever I am left with will be called complement of V. So, with respect to alphabets as the universal set, the complement set or complement of vowels is going to be what? Can you help me with that? All the consonants, or I'll say the set of all the consonants. Yes or no? Shall I repeat that, or everybody understood this definition comfortably? I repeat, complement means what? If in the context of Venn diagrams you wish to see the concept of complements, there you'll see a set. You will see its universal set. So if let's say this is a set A, so complement of A will be anything inside the universal but not A. Anything inside the universal but not A. So this thing here is called A complement or A dash. Yes or no? Are you still confused? Everybody getting it? So I think A complement in this context can be given by U minus A. So take everything inside the U, but not that part which is common of U with A. I hope you're understanding it. It means U minus U intersection A. I hope it makes complete sense. You're able to understand my language, able to what I'm trying to suggest you here. If I apply the same logic of complements in the world of real numbers, you would be able to process it more clearly. Let's say this is the set of all the real numbers. This is the set of all the real numbers. So all the real numbers between minus infinity to infinity are here. That's the set of all the numbers in the world. Now, if I have this as a set, which is the set of all the rational numbers. So these are all the rational numbers. So if I ask you the complement of all the rational numbers with respect to the real numbers, what will I get? Sir, I'll get all the irrational numbers. Are you still confused or do you get it? Because here I'll get all the rational numbers, for example, 1 by 2, 3, 0, minus 5 by 7, and so on. Yes or no? But if I look at all the irrational numbers, then they'll stay outside. So complement of rationals with respect to the real numbers will be the set of irrational numbers. Tell me in the comments, are you all able to comprehend the meaning of the word complement of a set? Yes or no? Everybody give me a quick response. Everybody comfortably understood this part? Yes or no? With this, if I could finally tell you the formula after which we'll start solving questions, I think two major formulae which we'll be discussing here is that first of all, number of subsets, I hope we have already dealt with to the power n. So number of elements in A union B will be given by number of elements in A plus number of elements in B minus number of elements in A intersection B. Sir, what if there are three sets? Okay, so let's say there are three sets like physics, chemistry and maths, or like A, B and C. So number of elements in A or B or C, that means A union B union C. What will I do here? I'll say number of elements in A plus number of elements in B plus number of elements in C. Principle of inclusion and exclusion. So something got included, I got to exclude it. So I'll say number of elements in A intersection B minus number of elements in B intersection C minus number of elements in A intersection C or C intersection C, whatever you wish to write. But again, there is a problem. When I remove it, the most common part, common of A, B and C got excluded totally. So I need to remove it, included one. So principle of inclusion, exclusion, inclusion. So number of elements in A intersection B intersection C should be brought back. These are those two very crucial and important formulae which we'll be using from now on in this chapter. So here we are taking a 10 minutes break and then we'll resume with our discussion on the formulae. So first part of theory is covered. Now I'll start with the questions. So very soon we'll begin with the questions after a 10 minutes break. It's 8 o'clock. We'll resume after this break of 10 minutes and then we'll continue. So there is a break of 10 minutes and then we'll come back. So if you all can hear me, if you all can see me, come back everyone. The break is over and we'll finally resume with the discussion part of the questions. So the theory part we are done with. Now we'll be moving towards the more, focused part where we'll be solving questions one after another. So without any delay, shall we get started? Here we have the first question for the day. Everyone, can you all see the question right there in front of you on the screen? Everybody, give me a quick response. Are you all there? Can you all hear me? If my voice could reach you, come back, everyone. Sit at your desk, start restudying. Yes, restart your studying or start restudying, whatever you want to call it. But I hope you must have hydrated yourself, you must have stretched, you must have walked around. Come back and let's solve the next part where whatever theory we have covered will get consolidated with these questions. And let's check whether you have understood all whatever we have learned so far or not. Shall we, everyone? So here comes the first question for the day. What does it say? So it says that here, write the following sets in the roster form. Okay. So first question here says that A is a set which contains X such that, I hope you do remember that this line over here represents or means such that X is a positive integer less than 10 and I hope you are understanding the meaning of this word, very crucial and important word, and is a conjunction. So this and this, 2 to the power x minus 1 is an odd number. I'll solve it step by step. So I'm writing these statements or the elements of A where I'll write X, which is positive integers, less than 10. Positive integer, positive 1, 2, 3, 4, 5, less than 10. So till 10. But I need to ensure that 2 to the power x minus 1 is an odd number. So I'll begin with x as 1. So if I try x as 1, what will be 2 to the power 1 minus 1? It is 1. So is 1 odd? Is 1 odd? Yes. So if 1 is odd, I will take this one, which is x. So 1 will belong to my set. Excellent, excellent, Moksha. I'm sure other students who are watching it with utmost sincerity, concentration, and focus are also willing to answer this question. Do it, try it by yourself. Now the next one. Can I try 2 here? Let's check it. So if I try x as 2, if I try x as 2, 2 to the power x minus 1. So 4 minus 1, is it 3? And 3 is an odd number. Beautiful. 3 is also an odd number. So 2 will also be an acceptable number in this set. Able to process this statement. Now, some of you must have cracked the pattern. If you haven't, shall I tell you? 2 when raised to any power. 2 when raised to any power will give you an even number. I repeat, 2 to the power 1 is 2, 2 square is 4, 2 cube is 8, 2 to the power 4 is 16, 2 to the power 5 is 32, 2 to the power 6 is 64, so on until 2 to the power 10 will be 1024. So here in this case, all the powers of 2 will be even from 1 to 10. And from those numbers, if 1 is subtracted, I am sure even minus odd is clearly odd. Even minus odd is clearly what? Odd. Noticing it, everyone? Or shall I repeat it? Yes or no? So what's my point? Sir, you could have tried x as 1, you could have tried x as 2, you could have tried x as 10 as well. All these values are acceptable values of x. So for the first set, set A, which has x, which is a positive integer less than 10, for which 2 to the power x minus 1 is an odd number, luckily, I'll take 1, 2, 3, 4, 5 till 10. All of these numbers will qualify. Positive integer less than 10. So it is not equal to 10. So I'll stop at 9. I'll not include 10. I'll stop at 9, which means my final value here in this series will be the last number, which is going to be what? 2 to the power 9, which is 512 minus 1, which is 511. That means for this, the value of x would have been 9. Tell me in the comments, everybody understood it? Why did we get these 9 elements in the set A? Excellent, great, beautiful, amazing, very good. How many of you got the answer as 1 to 9? Tell me in the comments, I'll be really happy. With this, shall we try the next question, the second one? Second one says x is a number such that x square plus 7x minus 8 is 0 for all real x. For all real x, where x belongs to real numbers. I hope it makes complete sense that you have started understanding or noticing these signs. So in this part, I think first of all, it's our primary job to solve this quadratic. So it gets solved as x square plus 8x minus x minus 8 is equal to 0. So why? Because here I hope you are noticing that 8 into minus 1 is minus 8 and 8 minus 1 is plus 7. Excellent. That's good, Geet and Magendrappa. That's brilliant. With this, the next thing which I'd request you to is, instead of factorizing in a shorter manner, what you can write here is the direct answer as coefficient of x is 8, take its negative and divide it by the coefficient of x square, which is 1. That will be the first value of x. Coefficient of x, which is minus 1, take its negative, so negative of minus 1, divided by coefficient of x square, that will be second root. So here the two roots are going to be minus 8 and plus 1. Minus 8 and plus 1. So here for this set C, if I wish to write it in roster form, it is technically a quadratic. It can have maximum 2 real roots. Its discriminant is positive, and I can clearly see by splitting the middle term, 2 roots minus 8 and 1 are going to be the answer. Again, I repeat, how many of you understood this? How many of you got this? Sir, this part can we do by splitting the middle term? Yes, by splitting the middle term, if you take x common here, you will be left with x plus 8. If you take minus 1 common from here, you will again be left with x plus 8. So that gives you two factors as x plus 8 and x minus 1. One root will be minus 8, another root will be plus 1. Are you all able to visualize it, imagine it, see it? Yes or no? Everybody understood it? Shall we move towards the next question in that case? Now you need to tell me true or false. Which of the following statements are true and which are false? Justify your answer. Shall we get started? So there are 3 questions. Let's solve each of them one after another. The first one, you can tell me your answers in the comments. The first one here. 37 belongs to the set where x such that x has exactly 2 positive factors. X has exactly 2 positive factors. Let's check it for 37. 37 can be written as 37 into 1. And 37 we know is a prime. So there is no other choice I have for 37. So factors means what? The divisors, the numbers which can divide 37. So I think 37 is divisible by 37 and 1 only. So it indeed has exactly and only 2 factors. So I think statement 1 is true. Everybody got it? Everybody comfortably understood it? How many of you could crack it? Were you all able to process it? Yes or no? All the participants. Shall we try the next question? The second question now. Pay attention, everyone. 28 belongs to a set. Oh, I'm really sorry. I did not read it. It says does not belong to. I did not read it. I'm really sorry. It says does not belong to. I'm really sorry. I made a mistake. And nobody highlighted. That's very unfortunate. It says does not belong to. Why did you not notice it? So it says does not belong to. So 37 does not belong to a set where I'm taking or talking about the elements which have exactly 2 factors. So 37 has exactly 2 factors. And it says 37 does not belong to this set. Come on, that's a contradiction. So if it's a contradiction, what will I say? That, sir, statement 1 is false. Got my point? Now look at this case, the second case. 28 belongs to the set where y is such that the sum of all positive factors of y is 2y. Okay, 28. If I factorize 28, say 28 is divisible by 1, by 2, 2 into 14, yes or no? 3 does not divide it. 4 into 7 is 28, 5 doesn't, 6 doesn't, then 7 into 4 is 28. I hope you're getting it. After 7, of course, I'll say 7 into 2, that's 14 will divide it. Then 7 into 4, that's 28 will indeed divide it. So here what am I noticing is that these numbers 1, 2, 4, 7, 14 and 28, they can perfectly divide 28. But what are they asking us? They are saying add all the factors. Add all the factors of 28. Add all the factors of 28. So what I'll do here is 2 plus 1, 3. 3 plus 4, 7. 7 plus 7, 14. 14 plus 14, 28. 28 plus 28 is double of 28. Is double of 28. It's double of 28. Now, please pay attention, everyone. What was the definition saying to you over here? Definition was saying that I will consider an element of a part of this set where the sum of all positive factors of y is 2y. So when I looked at 28 and when I noticed the sum of all the factors of 28, I observed that sum of all the factors of 28 was double of 28. Was clearly double of 28. So what will I say in this case? Will I not say that yes, sir, 28 does belong to this set because 28's factors sum is double of 28 as I could clearly notice it? Yes or no? So will 28 belong to this set? Yes, it will. So 28 belongs to, that's true, that's correct. So third question I think I can give you as a homework question. Sir, what do you mean by homework? Are you giving us homework over here? Yes. Homework we are giving you, that means this PDF will be received by you. Sir, where are we going to get this PDF? When you visit our website pw.live, so on our website you will get this course, CBSE Class 11th and Class 12 Boards Preparation. And there, this entire PDF, this one-shot revision of this entire chapter sets where we have covered the complete theory with a lot of questions will get uploaded. Yes, do believe me. At absolutely no cost, at absolutely free of cost. Shall I move ahead from here? Now the next question if I solve, let's solve these questions one after another. We are told in this question that x and y are subsets of the universal set U. So if I could picturize it, I'll say this is how the things are drawn. There is a set U. This is the universal set U and it has two subsets. Which two subsets? X and Y. Okay, so it has two subsets X and Y. X and Y are inside it. So this is X and this is Y. Everybody comfortably getting it? Now what are they asking us is, we need to prove, let me begin with this first one, that Y is a subset of X union Y. Now you tell me, what is X union Y, students? Sir, X union Y, if you plot this whole thing, as we have discussed when we were talking about Venn diagrams, this whole region, this white region represents X union Y. Yes or no? Sir, can you help us with the set Y? Where is set Y? If you notice, this yellow region here is your set Y. Now, how do you define subsets? Subset means elements which are taken part or out from a bigger set. So I hope Y is clearly taken from this bigger white set. The region wise, if I talk about the white region and the yellow region. So yellow region is clearly a part of the white region. Are you able to getting my point? Yes or no, everybody? So will I not say that if somebody asks me that Y is a subset of X union Y, so that's true. Because Y is clearly a region which I have taken out of X union Y. Everybody understood this method? Everybody got this idea, or shall I re-explain this, all the participants? Any concerns, queries or doubts if you have, please ask. Shall we try the next question? This part says, again a very beautiful and interesting thing, that here let's say this is X, this is Y. These are the two sets. This is X, this is Y. Now, can you help me with X intersection Y? I think, sir, we have already learned with Venn diagrams and everything. This white region over here represents X intersection Y. Remember that, everyone? Yes or no? Now, can you help me with the set Y, set X? So this region over here, this region over here, this region over here is your set X. Now, you are asked to verify, I think with Venn diagrams, I can do it in within seconds, where I'll say that I'm asked to verify that X intersection Y is subset of X. What is X intersection Y? The white region. What is X? This pink region. So clearly it is visible that this white region is taken out of this pink region. So it is quite evident and I can clearly see that X intersection Y, this white region, is a subset, a part of this bigger set X. I hope that is also very well proven with the help of Venn diagrams. Does it make complete sense? Are you all able to process it? Yes or no? Shall I move ahead from here towards the next question? Shall we? And with this, again, 2 questions I have gotten done. Third question I'm giving you as homework question. Sir, what do you really mean by homework? By homework, I wish to say that when you visit our website pw.live, there you can enroll for this course at absolutely free of cost. This course is totally free for all the students, where we'll be covering all the 11th and 12th boards subjects, which are physics, chemistry, maths, botany, biology, I'll say, and of course, English. These 5 subjects through these one shots. And once the session gets over, on our application pw.live in this course, for which you can enroll for free of cost, you will get the structured handwritten notes, these PDFs, at absolutely no cost. Can you believe that? Yes. Which means this entire session sets, which gets covered in this one shot, can be availed by you with not just this video, but the PDF as well. So if I'm giving you a question as a homework, once you receive the PDF, you try it by yourself. Will you, everyone? Shall I move ahead from here, all the participants? Shall we try a few more questions? Here we have another set of questions. 2 questions we have. Let's solve them one after another. Shall we, everyone? So the first question, please pay attention, everyone. The first question here over says that n is a set of natural numbers, but restricted till 100. So 1 to 100, these are the 100 natural numbers given in set n. Okay, great. So first question says, write the subset A of n whose elements are odd numbers. Come on, this is what they're asking you. Can you not help me with this? Set A, subset of n which are odd. So 1, 3, 5, 7, 9 till what? Till 99. That's it. The question is done. I'm sure some of you must be able to crack it. Second set, write the subset B of n whose elements are represented by x plus 2, where x is a natural number. Whose elements are represented by x plus 2, where x is a natural number, or rather x is a part of this set n. So if I wish to write set B, please understand, the least minimum possible value of x which I can take will be 1. This is the minimum value of x I can take. And can I take this maximum value of x from here? I can, but for this question, I cannot. Let me tell you why. Because ultimately, I am told that B is a subset of n. So let's say if I take x as 1, so B will have 1 plus 2. What is 1 plus 2? 3. If I take x as 2, B will have 2 plus 2. That's 4, then 5, then 6, and so on. Now, if I take, let's say 97 from here, so 97 plus 2 will be 99. If I take 98 from here, so 98 plus 2 will be 100. But can I really take 99? Because 99 plus 2 will be 101, and 101 cannot be there a part of B, because B is ultimately a subset of n. So if you're mistakenly writing 101 and 102 as well, you're making a mistake. Because for the second question, maximum value of x which I'll take will be 98. Because I needed to ensure simultaneously that B remains the subset of the set n. Everybody comfortably understood this idea? Yes or no? Shall we try a few more questions? Here we are with another set of questions. Let's solve them one after another. The first question here, what does it say? I hope everyone is paying complete attention here. It says that, sir, E is a set which contains these 5 even numbers, 2, 4, 6, 8, 10. If n represents any member of E, any element of E, then write the following sets containing all numbers represented by n plus 1. I think I'll do this one. Can you do this one by yourself? Can I give you this question as a homework question? I have a daughter, she's 3-year-old. So her teacher gives her this kind of, book. We receive this workbook every day after she returns from the school. So on one page, we see CW, classwork written. So that's where they make her practice. And HW is written. That's what we are supposed to get solved through her. So the same kind of philosophy I am following with you kids. Anyways, you are in 11, but we can still follow this method, which is followed for the kids. So you all are ultimately the kids, right? Kids of ours. So my dearest younger siblings, brothers and sisters, n plus 1. So I think n plus 1, 2 plus 1 is 3, 4 plus 1 is 5, 6 plus 1 is 7, 8 plus 1 is 9, 10 plus 1 is 11. That's your n plus 1. So can you not write n square? 4, 16, 36, 64, 100. Is it really difficult? I hope you will try this question by yourself. Now, let's solve few more questions based on sets so that you can understand it more clearly, so they can develop better understanding. We are told there is a set X which contains 6 elements. If n represent any member of X, express the following as sets. So I'll solve this first one first of all for you. This question here says that, let me read it for you once again. The first part here says that n belongs to X, but 2n should not belongs to X. A very interesting question it is. Let's say I write 1 in it. So if 1 belongs to it, what is double of 1? So double of 1 is 2. So 2 should not belong to this set, but unfortunately 2 belongs to this set. So 1 will not be a part of it. Am I teaching too fast? Are you able to process what I'm saying? Let me explain it with one more example. Let's say I consider an element 2 in this set. So if 2 is a part of this set, double of 2, what is double of 2? 4. So 4 should not be there in this set, but ultimately 4 is also there in this set. So 2 will also not be taken. Let us try and take 3. So if I consider 3, 3 can be a part of X. I think I'm making a mistake. I'm really sorry. N belongs to X. Let me read it again. I think I did not read it properly, the question. Let me read it again. X has 6 elements. N represent any member of X. Okay. Express the following as sets where N is an element of X, but 2n is not an element of X. I think we were following the right approach. So there, if I take n as 3, I think there we again have a problem, because I hope you're realizing if I take 3 as a part of this set, the set which we are writing here, so double of 3 is going to be 6. And I think 6 is a part of X. So I again cannot take this 3. But now if I move towards 4, I will without any hesitation take it. Because 4, if I take, double of 4 is 8, and 8 is clearly not a part of 6. Sorry, 8 is not a part of X, so 4 can definitely be taken. If I try to take 5, double of 5 is 10, and 10 is not a part of X, I can take 5. If I try to take 6, double of 6 is 12, 12 is not a part of X, I can take it. So for the first question, the answer will be 4, 5, 6. Are you all there, listening, watching, and understanding? Yes or no? Yes or no? So I think remaining 2, you will try by yourself. They are easy, simple, and doable. So those 2, I'm assigning you as homework question. I hope they are easy, doable, and you will. Let's try a better question now. This one, shall we? Looks lengthy, but we will be able to with some decent standard direct efforts. Let's see what are they asking us to do. So the question says, draw the Venn diagram to illustrate the following relationships among sets E, M, and U, where E is English, M is mathematics, I believe, and U is all the students of that school. Yes or no? So I need to solve 1, 2, 3, 4 questions. Let's see how many of these we do, one after another. Shall we, everyone? So if I now begin with the first question, first one I'll be solving. Pay attention, everyone. So here we are. This is your universal set, all the students of this school. And there I'll be having students who like English, and I'll be having students who like maths. Yes or no? So these are all the students who are into English. These are all the students who are into maths. The first question was, what does it say? It says, I think I need to read the question first. All the students who study mathematics study English, but some students who study English do not study mathematics. Okay, I'll process it again. I think I mistakenly draw something else. I need not draw it like this. I'll draw it once again. Don't worry. Have patience. Let me just remove this part. Let me just go through it one more time. What did it say? It said all of the students who study mathematics study English. So everybody who likes maths will be liking English. But there are some students who like English, do not study mathematics. I hope this is very basic and easy, where I'll say that if this is the set representing people who like maths, then there will be a bigger set representing people who like English. I repeat, these are the people who like English, these are the people who like maths. Repeat, pay attention, everyone. I am seeing everybody who is maths is in English, because anybody who is a part of maths is a part of English. But there are some elements in English, who do not study maths. I hope that's exactly what they wanted you to do with the first statement. Everybody got the answer to the first question, or are you still confused? Tell me honestly. Did you all get it? Now let's solve the second question here. Second question. Let's solve second one. Second one here says there is no student. Let's say we need to draw a case where we are drawing. There is no student who studies both maths and English. Okay, that's very easy, isn't it? What I'll say here is that, sir, first of all, this is your entire school, but there are people who like English, there are people who like maths, but they are totally, completely disjoint sets, which means people who like English and maths should be null, phi, void, nothing. Yes, because I need to ensure that people who is studying both English and maths should be zero. Getting it or not? Everybody. Everybody. With this, let's move towards the next question, the third one. The third one, what does it say? Let's solve the third one here. The third question here says that, sir, now you need to deal with the data which says some of the students study mathematics but do not study English. Okay. Some students study English. Some students study English but do not study mathematics. And there are some who study both. I think this is the ideal standard version which we have been drawing. This is the school, the universal set, in which there are some who study English, there are some who study maths. So I repeat, there are some who study English but not maths. There are some who study math but not English. There are some who study English as well as maths. So this is a clear, straightforward, direct representation of this third one. In that case, can I take the liberty to give you the fourth one as a homework question? Shall we? Can I give you the fourth one to be tried by you? Will you try this question, fourth one, by yourself? Sir, how are we going to receive this? I mean, if you're giving it as a homework, I hope I have been telling you this. There's this entire PDF you can avail at absolutely free of cost by following us on pw.live. There is a batch 11th and 12th boards, pure English, full-fledged English. So there you will get it at absolutely no cost. From here, if I could move ahead towards the next question, let's see what are we told. This question, again, a very good one, a beautiful one, and a very insightful one. It says, for all sets A, B, and C, they're asking you that are these two same? There are multiple methods, algebraic method, simple, basic, theorem-based method. I'll simply take the benefit of drawing it through the Venn diagrams. Shall we? Let's try and draw it with the help of Venn diagrams. So if I try and draw it with the help of Venn diagrams, this is going to be the LHS and this is going to be the RHS. And let's check whether LHS and RHS are same or not. So there are three sets. Which three sets? So I'll try and draw the best case. This will give me the possibility here. So this is set A. This here is set B. And this over here is set C. Now, please pay attention, everyone. This is A, this is B, and this is C. This is A, this is B, and this is C. Now, LHS I wish to figure out first. LHS. What is LHS? This expression over here is our LHS, and this expression over here is our RHS. And let's see whether they are equal or not. So, I'll simply follow the bracket part. Here I'll say A intersection B. Sir, what is A intersection B? This zone over here is A intersection B. Yes or no? Yes or no? Comfortably understanding this part? If you are not getting it, I could highlight it with this feature as well. Let's use this one. This region over here is A intersection B. Yes or no? Yes or no? Because this is whole A, this is whole B. So common of A and B is this. Where is C? I hope I need not highlight. This whole thing is your C. This whole thing is your C. So I need to take its union of A intersection B with C. So union of A intersection with the C will be this also. So this is A intersection B, union C. So this region is representing our A intersection B, union C. Comfortably understanding it. Definitely, if you are Outside India, you can also enroll. The enrollment is really simple. This is first of all a free of cost batch. So you don't really have to enroll by paying anything. It is totally free. For both 11th and 12th in English, we are teaching you through these one shots for the subjects physics, chemistry, maths, biology, and English. And with this, we are giving you the PDFs, notes, and everything, that too at no cost. I hope LHS is very well sorted. Shall we focus on RHS now? Okay. So RHS, B union C. What is B union C? So if I could highlight B union C, I hope everybody could see this is B union C. Yes or no? This whole thing over here is B union C. I hope you're able to understand this. Yes or no? So if that is B union C, I'll just highlight it like this. So that region here represents B union C. Everybody got it? Now, I need to take its intersection with A. I need to take its intersection with A. Check that description. You will get all your answers. Check that description. You'll get all your answers. So this is B union C. This region which I have highlighted here with this color is representing B union C. I hope you're getting it. So with B union C, I want to take its intersection with A. Sir, where is A? I think that I also need not highlight. This region is A. This is A. So its intersection with B union C is this part. Yes or no? The intersection of A with B union C is clearly this part. Yes or no? Shall I repeat that? So intersection of A with B union C is this. This yellow region over here, is your RHS. And this blue region over here is your LHS. Are they same? No, clearly not. Through Venn diagrams, I think we could prove it very easily that they are not same expressions. So if they are asked, we are asked to prove it correct, I think it was incorrect, and we have justified it with the Venn diagrams. Does it make complete sense? Did you all get it? Here comes another property. I think, do I really need to prove it? We already know this as a property, that's exactly the meaning of difference. Difference means this only. If I could show this to you, let's say this is our LHS and this over here is the RHS, right? So let's say there are two sets, set A and set B. So this is set A, this is set B. Here also I'll draw the same set A and I'll take set B. So what did I just say? This is set A, this is set B, this is set A, this is set B. First of all, let's talk about this part. A minus A intersection B. So what is A intersection B? Sir, this portion over here. This portion over here is A intersection B. So from this A, if I just remove this, whatever I am now left with, this portion, can you notice it? This portion is going to be A minus B, or rather this thing. So I hope it is completely evident and understandable that this region is what the LHS is asking us to draw. I hope it is very well sorted. Now what is A minus B? So technically, mathematically, if you know the formula, A minus B is actually this. So this is going to be true, but still, let's say we don't know it. So what is A minus B? So A minus B means take all of A but not B. So everything of A should be taken except the part of A which is common with B. So what is A minus B? Sir, A minus B is also luckily going to be this, because everything of A should be taken but exclude the portion of A which is common with B. So this portion which is common with B should be removed, and I think luckily that also gives you the same output. So they are indeed same, and we could again prove them right by showing it with the help of Venn diagrams. Shall we try one more question, everybody? Will you, everyone? Is everyone getting it? Is everyone understanding it comfortably? Yes or no? Now here in this question, what are we told? We are told that there are some sets A, B, and C where I need to work it out that whether it is same or not. The best practice is Venn diagrams, trust me. So here I'll draw my LHS, there I'll draw my RHS, and then I'll verify yes or no. So let's quickly draw all these three sets. The best case I'll take set A, set B, and set C. Similarly here also I'll take this set A, set B, and set C. Now, this is set A, B, and C. This is set A, B, and C. Let's see whether we plot the same region or not. Everyone paying attention? So here we are. First of all, what is going to be A minus B? So sir, take everything of A, but exclude the portion of A which is common with B. So what is going to be A minus B? So if I could highlight A minus B, take everything of A, but exclude the portion of A which is common with B. So this portion over here, which is of A common with B. So this white region which I have plotted is A minus B. Everyone able to make some sense out of it? If you don't get it like this, I will color it so that that shaded region looks more simpler and clearer. So this and this will represent A minus B. Getting it or not comfortably. This thing over here is representing your A minus B. I hope no confusion. Sir, can you help us with C minus B as well? Yes, we can. What is going to be C minus B? You help me with C minus B, students. Sir, C minus B means you take all of C, but exclude that portion of C which is common with B. Yes or no? Yes or no? So here if I plot C minus B, so take all of C, but exclude the portion of C which is common with B. So this is C minus B. Now one thing you might have noticed that when I plotted it, I did overlapping. I did a little bit of overlapping on a certain region, which was this. This belonged to both the green one and the pink one. So this region over here will be the intersection because green and pink have this region as its common region. I hope you're able to understand. Green got overlapped by the pink one, but I hope it makes complete sense that this region over here is our LHS. This white region, I hope, is very well understood by everyone. This white region over here is our LHS. Now let's check what does our RHS give to us. RHS says A intersection C. What is A intersection C? Sir, A intersection C, if I wish to figure out, I think that's easy. Why? Because intersection of A and C, this is A, this is C, so A intersection C is this. Beautiful, interesting. But it says from A intersection C, remove B, which means A intersection C, you take completely, but if A intersection C has something common with B, remove it. So I think this portion over here is common with B. So that needs to be removed. So if that needs to be removed, what I'll be left with is this. Yes or no? So this thing over here, this white region which I have just plotted is your RHS. Let me quickly check it. This portion was our LHS. The same portion is our RHS. They are same. So if they are same, I could prove that yes, they are correct with the help of Venn diagrams. There are indeed some other methods which you could have used, but I think Venn diagrams are also making complete sense here. That's a law of distribution which you can use. So this one I'm giving you as a homework question. How will you prove it? The hint is watch the previous 2 to 3 solutions and then try to do it with the help of Venn diagrams. And I'm sure you would be able to. Everybody getting it comfortably? Shall I move ahead from here? Let's solve the next question. This is a very good question. And I'll give you a very simple, straightforward example instead of confusing you. Let me define the set S. What is set P? Sir, set P is the set of all the prime numbers. So if I look at set P, I'll give you a very generic example, a simple, straightforward observation-based idea, which will help you in cracking it. So P is the set of all prime numbers. Prime numbers are what? 2, 3, 5, 7, 11, 13, and so on. These are all our prime numbers in the world. Now they say S is a number which contains T such that 2 to the power T minus 1 is a prime. Such that 2 to the power T minus 1 is a prime. Okay. So T I will take in such a manner that 2 to the power T minus 1 is a prime. I think it is very well related to that one question which we did in the beginning. Remember that 2 to the power x minus 1? Remember that, yes or no? So there if I wish to try and tell you by simple observation only, I'm not giving you the whole proof or the complete proof, by observation only, if I could try and teach you this version, 2 to the power t minus 1. So sir, whenever 2 is raised to a certain power, you will get an even number. So from this number, if you subtract 1, so even minus odd will of course be an odd number. So one thing I know for sure, that whatever value of t you take, 1, 2, 3, 4, 5, whatever value of t you take, it will give you an odd number, of course. But sir, is it going to be necessarily true that you will get primes only? Let's verify it. So here, if I take t as 1, so 2 to the power 1 is 1, 1 minus 1, sorry, 2 to the power 1 is 2, 2 minus 1 is 1. So first element is 1, but is this 1 a prime? I repeat, I took t as 1, and for which I took 2 to the power t minus 1, which I checked, and I needed to check whether 2 to the power t minus 1 is prime or not. So when I took t as 1, I looked at the value of 2 to the power t minus 1, which I received as 1. So 1 is not prime, so 1 will not be an element of my set. Now the next case, let's say if I take t as 2, will I take t as 2? Yes, I'll take t as 2. So if I take t as 2, 2 to the power 2 is 4, 4 minus 1 is 3. So is 2 to the power t minus 1 prime? Yes. So if 2 to the power t minus 1, which is 3, is a prime, so I'll take t as 2. So 2 will be my first element over here. Are you getting it? Are you understanding it? Are you processing it? How are we creating this set first of all? I'm giving you a very basic idea. In a very layman language, I'm explaining this. I'm not going it with the mathematical standard approach of proving a statement here. Let's say if I take t as 3. So 2 to the power 3 will be 8. 8 minus 1 is 7. And I think 7 is clearly a prime. So t as 3 will be taken in our set. Processing it, yes or no, all the participants. Let's say if I try t as 4. The moment I try t as 4, you will see the problem that 2 to the power 4 is 16. And 16 minus 1 is 15. And 15 is not a prime. So 4 will not be there in this part of set. I hope you are able to make some sense out of it. Yes or no? Yes or no? With this, the next conclusion will come with a 5. So the next number will be 5. So it will be 2 to the power 5 minus 1. 32 minus 1 is 31. And 31 is again prime. So I'll consider 5. So as you move ahead with this pattern, you will indeed notice that, sir, whatever numbers I'm taking here are prime. That's an observation-based method. It's not the standard proof you can give here. It is a general result that based on this, I have tried concluding the elements of this set, and there I am saying that yes, sir, S looks like a subset of P. But if you wish to prove it mathematically, you'll have to go beyond this. But I hope this method also makes complete sense and you're able to understand this, that how do we deal with sets, how do we write the elements, and how do we create the elements. Everybody got it? Now, let us look at the next question. Again, a very brilliant and a good one. How do we solve this? Let's have a look at this. From 50 students taking examinations in MPNC, Mathematics, Physics and Chemistry, each of the students has passed in at least one of the subjects. So I'll start plotting it. Here, I'll have maths, I'll have physics, and I'll have chemistry. So if somebody has passed some, which means what? People who have passed maths are 37. People who have passed physics are 24. People who have passed chemistry are 43. These are the numbers. At most 19 people passed maths and physics. So at most, this is 19. 19 means this data will be less than equal to 19, maths and physics. At most 29 maths and chemistry. So this is maths and chemistry. So this data is maximum 29, which means this will be less than 29 or equal to 29. Next part said, and at most 29 I have concluded, I think maths and chemistry, yes. And at most 20 passed physics and chemistry. So this is physics and chemistry, this region is physics and chemistry. So its maximum value will be 20, which means it will be either 20 or less than 20. Everybody got this statement without any confusion? Yes or no? Now from here, what is the largest possible number that could have passed all the three examinations? So this is what they're asking you, or rather is maximum value is what they're asking you. We know one thing for sure, that if this is the data which is 50, so number of students who cleared physics or chemistry or maths will be 50. Yes or no? So what's the formula we know? So the formula for number of people who could have cleared physics or chemistry or maths would be given by number of people who cleared physics plus number of people who cleared maths plus number of people who cleared maths or chemistry. I hope you're getting it. Minus number of people who cleared physics and chemistry, number of people who cleared physics and maths, minus number of people who cleared chemistry and maths, plus number of people who cleared physics and chemistry and maths. Remember that? So if I put the data here, please pay attention everyone. Before putting the data, let's understand the meaning of the word at most. Look at this. One thing I wish to do, that if I take this thing here, this value I know is 50, these values I also know. Let's talk about these values. Forget this whole expression. I want to talk about number of people who passed physics and chemistry plus number of people who passed physics and maths plus number of people who passed maths and chemistry. Sir, you cannot figure out this data, but what you can figure out is the maximum value of this data. Why? Because here, the number of people who passed maths and physics are 19. The number of people maximum who passed physics and chemistry are 20. The number of maximum people who passed maths and chemistry are 29. So 29 plus 19 plus 20. 29 plus 19 plus 20 will be the maximum number of people who have passed physics and chemistry or physics and maths or maths and chemistry. Everyone processing this data. So this gives you what? This gives you 20, 19 and 20. So 30 plus 20, 50, 50 plus 20, 70. 70 minus 2 is 68. So this data could be 68. This is the maximum value of this summation. Sir, what does it mean? It means that here, if I apply that logic, please pay attention everyone. If I take all of this data on the left hand side, so P union C union M, that's total number of students minus number of people in physics. Number of people who passed physics are how many? Number of people who passed physics are 24. Getting it everyone? Plus number of people who passed chemistry are 43. Yes or no? Plus number of people who passed maths are 37. Yes or no? Yes or no? Everybody getting it? So far, is there any confusion? Now, minus of this and this. So this is technically maximum of number of people who passed physics and chemistry or physics and maths or chemistry and maths, and that we have just worked out as 68. So this data given to us over here is 68. That is equal to the number of people who passed physics or chemistry or maths. And when you apply this data from total, if I subtract individuals minus maximum of this, I will get the minimum number of students, the largest possible number of students that could have passed all the three examinations. So this data over here will give me the maximum number of these students. Everybody able to process it? Yes or no? So with this data, if I proceed ahead, what do I say? 43 plus 37, how much is that? I hope we are not making any mistakes here. We are with this minus of this and minus. So this gets added. I'm really sorry. Why did I put a minus? Minus, minus, minus when brought here becomes plus. Yes or no? I repeat, when I put the maximum value of this expression here, when expressed here, I get the maximum of this as well. Processing it, everyone. So with this 43 plus 37, 43 plus 7 is 50, 50 plus 30 is 80, 80 plus 24 is 104. So 104 and 50, the difference is 54, but of course minus 54. And 68 minus 54, 68 minus 54 is, I think, 8 and 6. Yes or no? So that's 14. So maximum number of people who could have passed in physics as well as chemistry as well as maths would have been 40. Any confusions or queries so far? Are there any doubts? Shall I move ahead from here? Everybody understood that part. Now this is a very beautiful and an interesting question which you all must have enjoyed solving if you do it sincerely by yourself. This question over here says that here I am told each set XR contains 5 elements and each set YR contains 2 elements. Which means, let's say, if I talk about set X1, so it has 5 elements. If I talk about X2, that also has 5 elements. Similarly, X1, X2, X3, and so on, I'll have some X. Similarly, I have YR, which means Y1, Y2, Y3, and so on. So there are each Y1, Y2, Y3, they all contain 2 elements, each of them. Okay, that's good. And I am told here that union of all XR where R is from 1 to 20 is S. Union of all YR where R is from 1 to N is also S. Now I'll try to make you understand this based on a little different data. Let's say this is your school. Forget this whole question. Let me just explain this with a different data. Let's say this is your school, but I observe your schools, I'll classify your school's student based on different types of categories. For example, let's say I am here saying that there are some students in your school, but the students of your school are divided based on the sports they play. For example, they play cricket, football, or basketball. Or the same pool of students I am classifying based on the kind of activities they do. For example, let's say dancing, skits, I mean, let's say plays, or what can be other activity? Let's say painting, right? So these are the 3 activities. The same pool of students are classified based on the games they play. The same pool of students are classified based on the activities they perform. But here the best thing is that each of these sets will contain fixed number of elements. Here also each of these sets will contain the fixed number of elements. But these sets are also formed from the same pool of students. These sets are formed from the same pool of students. Are you able to digest this statement? Now from here, what is happening over here is that based on sports, let's say we have created 20 sports in our school. So there is first sport X1, there is second sport X2, there is third sport X3, and so on. There are 20 sports which are played in our school, let's say. And I am told that each sport is played by 5 students. So first sport X1 is played by 5 students. Second sport X2 is played by 5 students. Third sport X3 is played by 5 students. Even 20th sport X20 is also played by 5 students. So if I simply don't look at the data of the question, I follow the pattern. What I'll say is that there are 20 sports. Each sport is played by 5 students. So I would say that there could be 100 students in our school. There are 20 sports, XI, X2, X3, X1, X2, X3 till X20, and each sport is played by 5 students. So there could be 20 into 500 students in our school. But am I really making any mistake here? Let me read the whole question. I did not read it completely. Let me read it. I am told each element of S belongs to exactly 10 of XRs. What does it mean? It means, let's say there is a student 1. So student 1 will participate in actually 10 sports. So student 1 is playing X1, X2, X3, X4, and so on until X10. So student 1 is participating in 10 sports. So in this school, one more phenomena is happening, that every single student participates in 10 sports. Every single student participates in 10 sports. Yes or no? Let me just have some water, then we'll resume. Give me a moment. Just give me a moment, students. We'll resume in a while. So in this case, when I said that if there are 100 students in our school, based on 20 into 5's data, I'm clearly making a mistake. So what mistake? Every student is getting counted 10 times because every student is participating in 10 sports. So if every student is getting counted 10 times, you are actually counting everyone 10 times. So if you are saying there are 100 students, there are technically 100 by 10 students in this school. My point, yes or no? Everybody. So I hope this is how I'll first of all write the data. The same data I'll try and do for the YRs as well. What do I mean by that? Every YR contains two elements, which means Y1, Y2, Y3, and so on until YR. So there are R activities done in our school, like sketching, painting, dancing, drawing, skit, plays, theater, or movies, or anything like that. There are a lot of activities. So there are such activities in our school, and every activity has two students. So there are two students in activity 1, there are two students in activity 2, there are two students in activity 3, and so on. So based on that, how many students are going to be there in our school? Sir, we are having R activities. Each activity is done by two students, so there will be 2 R students in our school. But sir, there is a problem. I need to reread the question where it says that each element of X belongs to exactly 4 of YRs, which means here again I made a mistake. The mistake is that if I look at one of the students, he will say, I am participating in Y1, Y2, Y3, and Y4. So every single student is participating in 4 activities. So whatever this number is, every single student is getting counted 4 times. So 2R is not going to be the actual number of students. Actual number of students will be 2R by 4. And I think by solving this, you can crack the R. Yes or no? This will be 2. This 2 and this 2 are cancelled. R will be 5 into 4, 20. That's your answer. I'm sure some of you must have cracked it. How many of you did it by yourself? Tell me in the comments. I'll really appreciate it. If you quickly tell me how many of you genuinely solved it. Everybody understood this? Got it completely? Any confusions or queries? Let's solve this question here. Again, a very good question. I'll be conducting a poll in this case. So we are conducting a timeless poll. Here we have 4 options. You can participate in this poll by using Pylons. Everybody, shall we do it? Here we are. The question here says that there are 2 finite sets. They have m and n elements. The total number of subsets of finite set is 56 more than the total number of subsets of the second set. Okay. The values of m and n respectively. Let's say the first set is set A. Set A has m elements. The second set is set B, and set B has n elements. So, number of subsets of A, number of subsets of A will be given by 2 to the power m. Number of subsets of B, total number of subsets of B will be given by 2 to the power n. But what did they say to you? Sir, they said that this is 56 more than this. So what they are saying is that 2 to the power m minus 2 to the power n is 56. Processing it, everyone. So what I'll do here is, one of the best practices to be followed by us could be this, that 2 to the power m if I take common. Of course, this result is 56, which is positive. So 2 to the power m will be greater than 2 to the power n. It is basic and obvious. So if I take 2 to the power m common, if I take 2 to the power n, I should take common rather. So if I take 2 to the power n common, I'll be left with 2 to the power m minus 1. Getting it, everyone? 56 can be written as a product of a lot of numbers. I'll write it as like 8 into 7. Can I write it as 8 into 7? Because one of them is going to be even, other one is going to be odd. 2 raised to any power minus 1. 2 raised to any power is even, minus 1 is odd. Another one is 2 raised to any power is even. So I'm writing it, the 56, as a product of two numbers, out of which one is even, other one is odd. Now, if I just take the advantage or benefit of doubt here, where I compare this 2 to the power n with this 8 or equate this with this 7, I think I'll be in a better position to crack a lot of conclusions. So 2 to the power n, if I compare with 8, I think of n as 3. 2 to the power m minus n minus 1, if I treat as 7, so 2 to the power m minus n becomes 7 plus 1, 8. With this, 8 can be written as 2 cube. With this, I crack m minus n as 3. N we already know is 3. So m will be 3 plus 3, that's 6. And let's verify it. Although it will be verified, this is technically 2 to the power 6 minus 2 cube. What is 2 to the power 6? I think 64. 2 cube is 8, which is 56. So yes, it is correct. So what are we asked? Total number of subsets, the values of m and n. M and n are going to be 6 and 3, option C. I'm sure some of you must have participated in this poll and marked option C. Yes or no? That's good, Shrisha. I'm glad you are participating and you're there. Good, excellent. Keep it up. Did you all understand it? And it's good that you got the correct answer. Excellent. Shall we move towards the next question with this? Here we are. The set intersection this is equal to what? I think the best practice would be I simply plot it with the help of Venn diagram. Although the other method could be using the properties of distributions. So what do you really mean by that? I wish to say that if I take one of the sets, which set, let me, intersection I need to take, right? Ultimately, so this is A union B union C, intersection A intersection and its complement, so it will be inverted. De Morgan's law I wanted to teach first of all. So before I solve this question, I'd like to teach you De Morgan's law. De Morgan was a scientist, technically a mathematician. He came up with a law that, let's say, if you are taking A union B and then its complement. So he said you can take complement of A, intersection complement of B. How do we prove it? Let's say this is our universal set. This is A, this is B. So A union B, this whole thing is A union B. Its complement will be this. Yes or no? Now, if you plot A complement, that will be this. If you plot B complement, that will be this. And if you take its intersection, it will be same this. If you just do it by yourself, you'll prove it very quickly. So De Morgan not only said this, but he also said that here, if you take complement of A intersection B, then it will be complement of A union complement of B. Thank you so much, Vijay. I hope no confusion so far. So this De Morgan's law you can apply on this question. So there are two methods I'm suggesting here. One of the methods is that you use De Morgan's law, which is going to be a very good approach here. And otherwise, what you could have done is you could have simply thought of Venn diagrams. Let me use De Morgan's. Venn diagrams you must have done a lot many times. So let me try and tell you one more approach which you can always think of. So this is A union B union C. This is intersection of De Morgan if I say. So there are intersections. So they'll become individually. I'll have A complement, intersection will become union. Complement of B, complement will be B. This intersection will become union. Complement of C, complement will be C. So that's what I'll get. And of course, its intersection with C complement needs to be taken, which I'll do later. Everybody with me so far? Now, for a while, just to make you understand this, let's say I say B union C, I'm denoting by a set X. So how is it written? This is written in a little different format where this B union C, I'll be substituting by X. This B union C, I'll be substituting by X. Now, there's one more very interesting property. I did not understand your query. Can you be more specific, Mr. Saurabh Tiwari? Good, very good, Saurabh Tiwari. Coming back to this, I am saying this is A union X, A dash union X, and its intersection. So I can write this thing as A intersection A dash union x, and what is x? X is B union C, and its intersection with C dash needs to be taken. Everybody comfortably processed it? Any confusions or queries so far? If there are, please ask. Now tell me, intersection of A with A complement. Imagine this. This is A. This is A complement. Is there anything common between them? Nothing. So this part over here is phi. So phi union B union C intersection C dash. Getting it, everyone? Getting it, everyone? Yes or no? Yes or no? Now, phi union anything is that thing. Because phi is nothing. So nothing when merged into something gives you that something only. So this phi will simply vanish. So I'll be left with B union C whole intersection with C dash. So distributive property I'll apply. So I'll say that here, I hope you are processing it. B intersection C union C intersection C dash. I'll do here. First of all, B intersection C dash union C intersection C dash. So again, I'll tell you what is C intersection C dash. So that's phi. That's phi. So here, this is phi, this is union, and this is B intersection C dash. So union of anything with phi is that anything. So my final expression will be B intersection C dash, which I think is given in option A. You could have done it with the Venn diagrams as well. If you want, you can. I'm simply using the basic properties of these, and that's how I'm doing it. A and B are two finite sets, then NA plus NB is equal to, I think there is some mistake here. What is this question? I think there is something wrong here. I'm really sorry. A and B are two finite sets, then NA plus NB is equal to what? Something missing. Okay, yes. So they're asking you a formula. I did not get it. I'm really sorry. Look at this. Do we know A union B? That is NA plus NB minus NA intersection B. So NA plus NB will be what? I hope you're getting it. NA plus NB will be what? NA plus NB will be N A union B plus N A intersection B. That's your answer. Everybody got it, or shall I repeat it? Yes or no? Yes or no? Let's try the next question with this. If a set contains n elements, the number of subsets of A. Number of subsets of A is always 2 to the power n. We have discussed it as a formula. I think nothing needs to be told about this. Now you tell me whether it is true or false. Whether it is true or false. Do we have the feature of poll here again? Let's check it. So single choice, multiple choice, and additive type. So it does not give us the choice. So I'm doing a poll where A option you should mark if it is true, B option you should mark if it is false. C and D you shouldn't. Right. So let's see how many of you get it right. I've started a poll. Everybody, try and do this. Try and attempt it. So here comes our question. Let's do it, everyone. It says R and S are the sets defined as followed. R is a set which contains integers because Z is an integer. X is divisible by 2. So technically all the integers which are divisible by 2. So here I'll be writing it as 2, 4, 6, 8, 10 and so on. S is a set which contains all the numbers, integers, where it contains elements as y, where y is divisible by 3. So it's like 3, 6, 9, 12, yes or no, all the multiples of 3. So it says R intersection S will be 5. Come on. The numbers which are divisible by 2 as well as 3 will be 6. I mean divisible by 6. Look at this 6, then 12, then 18. So is it 5? No, that is clearly false. That is clearly false. So I'm sure if you understood it, you must have marked option B. I did ask you to mark option B. That's good, Shrisha. That's brilliant. I hope you must have used the same logic. Next question says, Q intersection R is Q, where Q is the set of rational number, R is the set of real numbers. I think that's very basic and easy. If this is the set R, all the real numbers, if this is the set Q, which is the set of all rational numbers, so Q is clearly a subset of R, a proper subset of R. So if it is a proper subset of R, you tell me what will be the intersection of Q and R. So what is common between Q and R? You imagine this by yourself. You see rational numbers and real numbers. What is common between rational and real? Rational is a part of real. Rational is a subset of real. So common between rational and real will be rational. Yes or no? Yes or no? So they said that Q intersection R is Q. I think that's true. Everybody understood it. Is there any confusion? Query? So we are done with this chapter sets. In the next class, we'll start relations and functions for class 11th. So don't worry about it. We'll do it. Everybody got it? Any queries or confusions? My homework will be that if you're preparing for boards, solve your NCERT books. They are always sufficient. And then you can follow any reference standard material prescribed by your school or good institute. What I'll suggest you is that if you're preparing for JEE, this is very basic and very easy. Sets as a chapter is huge. It's amazing. So if you really want to prepare for JEE, solve PYQs of JEE Mains first. At least last 6 years, that is 2020 onwards, PYQs you should start solving. This one shot was definitely not the JEE level. This was simply board level, basic standard formulae questions we have done. So if you want a board level understanding, you would have done it. But if you want JEE level understanding, you can switch to our PW JEE English channel as well. There we are conducting one shots. For JEE Mathematics, Chemistry and Physics as well, for all the chapters of 12th standard as of now. So that is all. I think you must have learned, enjoyed, and gotten a lot of inputs. This was our first session in that series. Very soon we'll come up with such more sessions. So I think you have gone through a lot. You must have understood a lot. You must have gained a lot. But if you want this PDF, this entire chapter sets PDF, if you want to have, all you need to do is visit our website pw.live. There you will find our course PW Boards English CBSE at absolutely free of cost. That will be totally free. If you just enroll for it, you will get this structured, detailed handwritten notes at absolutely no cost. Trust me. So with this, I'm calling it a day, hoping and believing you must have understood, learned, and enjoyed a lot. Any concerns or queries if you have, please ask. I'm here for another 1 minute and then we'll call it a day. By the way, thank you so much. You have been a really great audience. I really appreciate that some of you or most of you must have studied sincerely here. Shall we call it a day, everyone? Give me a quick response. All the participants. Thank you so much. Take a good care of yourself. Good night, everyone.